still one person shy, but yeah, let's start it. Hi, good morning. This is great classes. My name is Byung Han. It's right down there, and then also my email address. And I'm a senior application engineering manager in Johnson Control OEM solution side, and I've been with Johnson Control, as I mentioned already, but since 1985. And I started with a JC80. That is just a microprocess computer. It's about the size of that refrigerator. And then JC8540, which is the first PC version of that our OWS stations. And then Metasys is released at 1990. And after that, we actually kind of a staging up. And then, the revision is now almost 16 different revisions, passed by. And now since 5 years ago, I joined the OEM side. I used to be at the branch operation. I support the North America, technical support team. But I joined the OEM solution since 5 years ago, and then I cover since that, and maybe you guys saw or not, but I support the peak controller and Metasys, and then M4 series, F4 series, anything, and then now it's like mainly I support the EGIO. So, and if you see it, but you call maybe technical support teams in Brody Precisions or Johnson Control technical support team, and if you don't get the answer, and then at that time, maybe you can just contact me, then I can give you some answer. If I don't get, then don't worry, I'll find out from my resource team, and then I can get back to you as soon as possible. But don't expect me to get answer by right away, because I'm moving around, and also I got a bunch of projects to cover in nationwide. I support actually OEM manufacturers to kind of I design for them or create for them for solution, not only just controller, but we talk about the real solution. How do they run the boiler? How do they run the chiller? I face with all kind of weird mechanism, So just like a data center, modular data center, now I'm involving it with the work with the Dell, that the data center is actually semi-truck length, and then that is a port and movable. So it's just like one building need more data center, they can use that modular data center. Those things. So. And
if you guys didn't get the Bluetooth, the 5 guys here, just put BT next to your name when you sign in. Okay, they'll be coming in.
They're coming in this week.
Yeah. Just want to make sure we get.
oh, you get the CGM 090. That's good. Yeah, so that whatever you got right now, that the F4 CGM 09090, that is, I think it's the most advanced controller in F4 series. I mean, field controller. And then CVM is just, VAV boxes. But CGM, you can just play around, and you can program it, you can test it. I using F4, but I usually use M4, honestly, M4. And because I got all license on the M4 series, but F4 series, once I get into it, I have to get from the Niagara, and the Niagara is like, end up to different software, so I'm not using them much, but the software what we are teaching today, CCT, is same as whether M4 or F4. Only difference is you are licensed, that's all. So CCT license. I am gonna using today's CCT version 15. It doesn't much changes whether if you have a 16, it's still nothing much changes. So don't worry about it. Is anybody has? Everybody has like a new tool. I don't know. I brought it or not. For because I used to love it. BT CVT, the blue color one, and now it is being obsolete. Now they just send me to new one. Oh my God. Good thing it's a small. BT-CVT usually like, but I love the BT-CVT, honestly. And if people asking me how was it compared to BT-CVT, and then what is that the other one? That is damn things that I hated. That yeah. This is pretty handy. This is pretty handy, and just you need just phone jack cable and supply with it, and then plug into your controller, power on, and you select the mode, and then just link so easy. So it's very handy. It's very handy, and then it's Wi-Fi, so it's kind of a more long distance than a BT-CVT. BT-CVT is Bluetooth though, but this is Wi-Fi, so this is pretty handy. Yeah, it's a TL. This is TL-CWCVT. So, but you'll get it. You'll get it. And
Is the map gateway going away?
well, they yes. Anybody like this map gateway?
It's already price obsoleted.
Yeah. Map is I had nothing but just headaches with the firmware. People crying, and so we have to fix the firmware here, there, every time. And then finally we decided just put it down on the table and then put the new ones in here. So this is very handy.
We haven't had much luck with it.
Oh yeah? Really?
Honestly, yeah.
Oh.
Unless our laptop's plugged in, it doesn't stay connected.
Oh. That's weird. I don't have any problem so far, but we'll see. Well, if you have those kind of experiences, please, especially, that describe, very, summary that, why, the scenario, and then please send to my email. Then I can just, really escalate up to the, my technical teams.
Yeah, I don't know if it's a laptop, still wouldn't say Dell, but
No, anything. It doesn't matter because we have to be really, kind of get all the, feedback so we can just improve it, something. But this is first time I heard it, so
yeah, I think there's other people in the community too that complain about it.
please. Yeah, the more complaining is better. So then we can improve it, something. So
Does Frank know about it? Yeah.
I don't know that, we just kind of threw them on the side for the hell of it.
Okay,
and now it's-
let Frank know.
We'll check and see how many keys exports we can take out.
please. Yeah.
We tried it with 5 or 6 different people.
Yeah, if you guys get that stuff, just email the tech support and let them know. That way our guys can start tracking.
Yeah.
We have customers off down these.
Right.
So, and then if it's a bigger issue they see, they'll get it over to Johnson's guys and start working.
Yeah.
So,
Yeah, so you guys have a direct connections with the Brody Precision, so please, forward to them, and then they can forward to me. If there is a need to really pay attention, then, we'll work on it. And yeah, we are working on for a few things, but, this is new one that I heard. And yeah, good things, you already have it, but I went last time to San Diego and west side for the customers, and then they didn't even have this one. They just like, what is that? It's like, oh, this is a new one. And they didn't even know. They're still using that map tool.
Boots up a lot faster.
Yeah, it is faster. Yeah. All right. So today we're gonna cover, we're gonna cover CCT. This is a CCT advanced training classes. Is anybody here that see the first time the CCT? Good. Because I saw some guys raised. I was like, oh yeah, I just got hired like in last week, and it's like, oh my God. But anyway, he followed very well. He said he used to program the PLCs, so he followed very well. But anyway, today's classes, I'm gonna focus into the VAV single duct unit, and I throw like kind of kind of advanced classes. So I throw like now the new ASHRAE things like ASHRAE standard 62.1 and ASHRAE for G36. I don't. But now they just require. Because indoor air quality. People now just like very concerning about the indoor air quality. Because they said like, oh, human being is living inside the inside a building is about 70% of their life. So they said, oh, indoor air quality now a very big issue. So especially California. Oh, California Title 24, forget it. That's like they're really only concerning. It doesn't matter. They're only concerning about that. Yeah, people. That's all. So that's good. That's good. So now I'm gonna put the today, so we're gonna throw on some kind of those future. So I'm not sure that how you guys are doing that. Executing the job at the field, like a VAV controller. Are you guys programming or just just got the programming and loading it, or commissioning it?
For VAV,
Yeah.
usually just use the can.
Oh yeah. Just can program?
Yeah, just go through, for doing CCT,
Yeah.
typically, yeah.
Oh, good. So now so you mean that is you know how to program the CCT. That's good. So usually when you guys program it, you will get like a drawing, engineering drawing, and then just simple. I just throw that like supplemental heating for especially if we are in the cold environment area. We always, see that the supplement heating, like, fin tubes, the radiators on the, window side. That was funny that, I talked about that there's supplement heating at the, West Coast. They said, just, what is it? And I said, forget it. And then I'm going to using that NS8000, for the, zone 10, zone humidity, and the CO2, and so on. So this is a simple, just a, flow diagram that I always, focus on that the people that when you program it, please look at the engineering drawing. Make sure what you got and what you don't have. You don't have to put so many things if they're not in the drawing. They're not required. Sometimes they don't even have that supplemental heating. And then sometimes they don't even have a supplier temperature, actual supplier temperature sensor. They may just get that from the network input. And also that sometimes I see that some people that they don't even using discharge air temperature. They just using only just network sensor. Well, it's okay because discharge temperatures usually I am encouraged to using it to cascade discharge air temperature set point. Otherwise, if you're depending on to the zone temperature, it'll take a cycle time. The tuning is more difficult. Because it's warming up the space. If it's small rooms, fine. One man office is okay. But the conference room, it'll take for a while. And then how many times, what's the usual typical commissioning time that allow for the VAV? What, 15 minutes? Yeah. If you're spending more than 15 minutes, you start losing money. That meaning is, whoever program it, has to be simulated many times to make sure when they're ready, through at the field, so minimize that, minimize the commissioning time. That's the main focus. This class is for that. This class is, I want you guys programming it, simulate it, and then validate it. Make sure that you have guaranteed a 15 minutes commissioning time for the real field verifications. Sometimes I see that when I was in branches branch operation, people calling like, hey, we got the program from the system engineer, and then it'll take forever to tuning and so on. And then, well, there is so many scenarios that can be happen, but mainly is what? Maybe someone who programmed it, he may be trusting himself for, his knowledge or experiences, and maybe he just kind of skip up a little bit about that, real validation. So that is happening. So please, so once you program it, just, make sure, just check, whatever you needed. Just, what is it? Heating cycle, cooling cycle, the satisfaction cycle, 3 cycle. You can just test it with the John 10, up and down, whatever. And then make sure that the damper output is, is correct, really, once you need in the cooling mode, make sure that your damper output is incrementally go up. When it's cooling, make sure that you are in the heating flow set point, so on. So this is our today targeting. And then because I really broke down CCT in the these PowerPoints. So total 176 slide. I'm not going to cover all, but I broke down really detailed. I'm going to give it to you guys for the PDF file, and then you guys can just look at it. And if you can adding up more stuff, then you can use for future your references. That's it. But whatever you see, the modules, the logics, I put every slide in there. So, and some explanations and so on. So you will understand. Hopefully, you can understand easily for the CCT on the VAV. Once you understanding VAV, the single duct, today that we're going to focus on to it. After that, mixed air unit, air handler unit, anything will be just maybe come in the puzzle easily. So we're going to cover up especially a state table. Everybody just like, some people really don't like the state table. They says like, what is it? And then, why? I mean, a state table is one of the main benefit for the CCT because it has a metric. That's the metric, metric. So far left column is what? That's the priority level. And all the other, the right side one is just column is what? Just the future, function, logic. Only you have to concerning about it, the priority on the left column, first left column. That's the priority. So you want a high priority, put on the top. You want a lowest priority, put on the bottom. On the right side on the column, it doesn't matter. You can be switching around. Only you have to select the future. When this on the left side of priority happen, what do you want to do action in the right each column, like output control side. So yeah, this one is we're going to cover up. Don't worry about it. And then CCT, once you pop it up, we're going to go to, but we're going to go for detail. But I'm not going to go for basic. I told you this is advanced classes. So anyway, we have kind of a column here. First column, second column, so on. So CCT actually designed by MIT people grouped together. And what it does is a flow like from left come in and right go out. That's how they designed it. That's why it's all the input, whether network input or hardware input. Don't worry about the miscellaneous. This is just a pseudo point from the output to decide the priority also. Anyway, all the input coming in. And the next is what? Miscellaneous and set point. Decide any miscellaneous, any set point, internal set point. They start, decide it. Go to the next is, state generation. Meaning is create conditions. So whenever that, what do you want to do? In that case, is when fire happen, when a low temp trip, or when is occupied, when is unoccupied, what do you want to do? This is the state generation. After that, the one is behind, is this guy's state generation, tossed into the state table. It's not showing it here, but the state table right here. They just toss into the state table and then let the state table to decide to what future you want to do on the output control module. So state table will decide, hey, box, whatever that the cascade decides temperature, you do this. Because now we are in heating, so you do the heating reset. Now we are cooling, you do the cooling reset. And then whenever they decided, when they done it, they're going to start sending out the output to signal to network output or actual hardware output. Easy, isn't it? I mean, you guys already know. So, but maybe some people, maybe focus too much into program. Maybe they didn't care much about how they flow. You don't have to really worry about it. Oh, maybe my decision was from back and forth. It's okay. But as much as possible, that encourages from flow from left to right. Why? In future, maybe you step up to the another level in your groups, and then new guys coming in, and then he send out at the program. I mean, it's your troubleshooting, and if this is a consistency and standard for the all your operation, even the new guys coming in, they catch up fast. Troubleshooting time is less. Same thing. Troubleshooting time is longer and longer. We lose money. So that's why it's like from left to right, kind of that is kind of a standard flow, and then that'll be help to also troubleshooting too. But I didn't apply much anything. I think there's maybe a couple, but mostly it's standard. But I'm going to share this CAD file after we done class. I'm going to send you guys all email for my CAD file. Oh no, I'm going to send it to Tom, and Tom can maybe distribute to you guys. I got not only this one, I also got the PID prac tuning reference. Guide, and plus that I got some PDF file for like what the hell is the G36, what is a standard ASHRAE 62.1, and those things I'm going to send out everything to Tom, and Tom can maybe distribute to you guys. Because I got so much Johnson Control, they are now restricted, sending out the email to the outside of Johnson, so sometimes they're blocking. So anyway, so today, just like first we're going to cover up that set point side, and the next we're going to set, so on. So this is the marker, whatever I put it in, the meaning is the first session and so on. Anybody has a question about that here? I'm not going to focus on that much, but on the network or hardware input. Okay, anybody have a question about the P2P? Point to point. P2P is, everybody know, right? So, especially VAV boxes, sometimes I see a lot now these days to using P2P because what? Oh, yeah, but P2P is only you can use when? I mean, what condition? Same trunk, right? Yeah, same trunk. So now in the building, main hand, all the VAV boxes, they say, first floor, east coast, east side wing, they have they have 50 VAV boxes. They're using one main handle unit 1. And if I am engineer, I'll put the same trunk, all of them, in one trunk. So they can share the peer-to-peer. What's the benefit between main handle unit to each VAV boxes? So when VAV boxes, everything is, all 50 VAV boxes. If there is a more than certain percentage, that's on the spec usually, say anything, or maybe say 1/3 of the group opening up the more than 85%, what they're asking, raising up the static pressure set point. Or anything that the group, that any zone CO2 rise up more than, maybe say 20% of the boxes require, CO2 sensor level is maybe overreached the 1,000 ppm or whatever that the limit, high limit. How they do it? Main handle unit, they have to open up the more OA damper to bring in the fresh air, right? Those things. If you're using the J's, if you're using some of the trunk, you have to send out the supervised devices, getting it, and sometimes it's like a time lag, and then sometimes like you will see that the main handle unit swing the speed because of time lagging. But if you use the peer-to-peer in the same one trunk, air handle unit, and with all 50 boxes, whatever, that all getting air from that air handler unit 1, then we can create call the P2P point. And then in air handler unit, on the network input, we can put like a VAB 1 through 50 network input point and assign the P2P point from each devices. And then we can get all that, say, requirements or requesting, triggering binary points, whatever, it doesn't matter. And then you can you can use that to the air handler unit to reset the OA damper or reset the static pressures. Well, when the stop box is all closing down, and you don't want to put like a supply main handle unit to always set it, say one inch water column pressure. You don't want to put in the 1 inches all the time because it's going to be what? Pressuring the boxes. To do that is you can just raise down. So what is that? We call now the stream and respond logic. So maybe you never pay attention, but this is coming now a lot. Like most college, university, group, campus, they are requiring stream and respond for the main handle unit. Same, that is this feature. When boxes start closing down, bring down the set point. When boxes start opening too much, that's to bring up the set point of this static pressure. And those things. Now, you are the guy. You are the guy that who can give the solution to customer. That's why CCT is not just answering question and programming. No, it's not. It has more than that. Answering question and done, that's a standard. But you have to put sometimes more feature in there, P2P points. And maybe one box, there were 50 boxes. Maybe one box has like a leftover the point. So, maybe customer said, I want to using that for my secondary chill water pump on somewhere in the building, but nearby that box's controller. And then you can do it. And then one controller pick up that pressure, water pressure, and then one pump in the far maybe somewhere control that pump. How? P2P. Why they using supervised devices? Supervisory devices, what? The speed is what? Longer. If that the traffic, protocol traffic communication traffic get increased, that supervisory devices control is going to be slowed down, meaning is what? The pit loop will be going swing. But the P2P is the same trunk, and they continually sending out. Whenever changes, they sending out, so you can steady control. I see those things a lot, especially wide campus like university. I use a lot at the University of Chicago and then University of Wisconsin campuses. They just using that a lot. Because at the customer side, they want to using every single points available. Because they want to save money. So that's another thing. So we're going to concentrate also once this one done, and then we're going to concentrate also how to create the side loop. The side loop, people just go there and just like selecting side loop, the future, and so on. But once you know how to program why you needed it, you can just create your own side loop. Side loop is usually the what? Just input, output. That's all. Just like you control that to say simply. Yeah, you control maybe like a binary input by binary devices, like a lights on, lights off. When that outside sun dusk time, lighting control. You can do that. Just like photo shell on the outside, dry contact, bring it in. Whenever the de-energize it, turn it off. Turn on. When energize it, turn on. Whatever you want to do it. Analog, pressure control to pump speed, variable pump speed, those things. So we're going to cover all those things. And before we go that far, okay, so now, how I done is, this program, whatever I create that I'm going to share with you, is I selected from CAM program. CAN program. This is a CAN program is VAV boxes. I use always CAN program, but 800 units sometimes I using just full custom program. Why? Because it's some 800 unit is just like way up, kind of the specification is way difficult, or kind of a high advantage ones, like a hospital surgical room 800 unit, dual fan. Because why? They always design the dual fan because they don't want to, any emergency case they shut down waiting for the fix. So one down, and next is standby, kick on. Or sometimes like a lead lag, balancing up, and those things. So, but the VAV, stick into the CAN program, please. Do not using anything else. Because VAV, why? VAV box is what? We have a balance override feature. The balancer can go in there and he can do whatever he want to change it to his pickup gain, area, whatever. Because we just throw in there all the feature. Of course, we're going to put the right space, area and so on. But the pickup gain, that is all but done by the balancer. So he can change whatever he want to do it. And just, answering those things, so is there, I don't know, I just use the standard. So all incremental output. But once that come down to box heating, now I see a lot of people using now proportional valve because easy because of one output. But incremental using two outputs. But it is up to what the design is. And like a supplemental heating also. Now we're using, I apply the incremental. That's the default usually. And two incremental is what? Full output. And sometimes they, kind of what, installer, they wiring backward for clockwise, counterclockwise. And sometimes like this valve, these boxes has like, output is reversed it. This one is polarity change. You have to keep changing it. And then once they start mixing it, if that building has, say, 200 boxes, they are not consistent. That's the really problem. That's why it's like proportional valve is maybe more better. Just, plus and minus, it cannot be changed that much. So that's another tip, but it's all depend on spec. Spec said incremental, then it had to stay in the incremental. But once you get the incremental, please do not swiping in the software to polarity. Change at the actuator. Because if you keep changing in software for each boxes, then you're in trouble. Because the next time somehow that the control is bad or whatever, if you push down, you cannot push down anymore for the massive downloading. You have to do one by one. That's really pain. And then sensor, supply temperature, I put it in, but 80%, they're not using the hardware, actual hardware, sensor. They usually just a network share point from that, supervised devices. But also, I mentioned to you, if there is a main handle unit, and with the same trunk, we can use the P2P. On the next network input, you can define the supplier temperature and define that is a P2P points, and then assign that 800 unit MAC address, and then in 800 unit, the supply temperature analog instant number, you define it, then it'll pick it up right away, boom, boom, boom. And then supervised devices, J's or anything, they don't have to do anything. Because now we are talking each other, controllers. A lot better, a lot steady. And zone temperature, I select the set point adjustment, and then I just use the common set point. Common set point is what? So you can see the actual temperature. But the VAV, yeah, of course, that they are always, they have also spec especially big campus, they're always using the warm and cool adjust to give only 2-degree offset. Like, so make sure that, field guy, the people cannot just dialing up and down, way up and down high. I see most of the campus, maximum they give allowance is a 3-degree. Yeah, University of Wisconsin was a 4-degree, but they start bring down to now even 2-degree, plus minus 2-degree. So why do that? Because there's some people, same, we see all this, right? Same area, one person get feel hot, one person get cold. So make sure they're not dialing up and down like a crazy. So they give just warm and cool down, deadband offset for 2-degree or 3-degree, whatever. And temporary occupancy sensors, support, meaning is there's a push button on the NS8000. There's a feature. Some sensor has it, or sometimes doesn't. But if they have it, if you push it, like a night crew, when they're coming in, cleaning it, and that they don't, like a summer, like a stubby at night, you don't want them to starving at that environment. So you can just push button. Temperature occupied, meaning is just push a button and then it'll just cycle fresh air, otherwise just cold air blow in. Of course, the man handler has to kick on. But it's all depend on also that the spec required, then you have to put it in. And then, yeah, and then here I select the occupancy. But occupancy usually they don't use much with the NS8000. They're using from that portal shell light, light sensor, whatever, and then they just tap out the dry contact. They adding into actual hardware input, so it's all dependent also. And this is a funny one. Used to be CCT version 14 or whatever, they didn't have this column right down there. Now they have a new guideline 36. What is guideline 36? Anybody has been looked? Yeah, guideline 36 is just a new code that just increased by the ASHRAE. I don't know. The ASHRAE people always make like a funny one, but guideline 36 ASHRAE that the minimum occupancy flow set point calculation, and ASHRAE they want to follow the ASHRAE 62.1, or if that job is in a state of California, you have to select the California Title 24. And then, a ventilation time average used to be how we calculate the supply air flow set point in VAB. When zone temp is climb up, we bring up the CFM increase, right? When need to cool down, we'll lower down the CFM and just maintain between heating mean and then max flow, but always just maintaining the heating mean. But since that the now guideline 36 is coming in, is the same. Actually, if you look at the digging up that logic, it's only almost the same. But anyway, they just put down now they want to relate with supplier temperature, discharge temperature, zone temperature, and then well, it makes sense, but to end for the field people, you have to now think one more. Just that new one, new logic, new option, guideline 36. It'll hit it. It'll hit to all nation sooner or later. So now it is better to understanding what is it. So I'm going to share that also, that file. And what is this California? What is the guideline 36 and so on? What is it? Here it is. ASHRAE guideline 36. Look at it. I'm not going to talk about this one, but just this is it. So you have to read it, understand it. Oh yeah, now I'm make a sense. At least there's somebody asking you that, hey, what is the guideline 36? You can just kind of answer it. Then now what? Oh, this guy is really smart, and especially commission agents. They coming to you and they're going to start, commission agents usually always what? They're not that really good, friendly. They always try to be, kind of a managing, especially managing us. So, but, you talk about, oh, yeah, Kelvin 36 and so on. This guy like, oh, shit. He's not going to bother you much. But anyway, I'm going to share, don't worry about that. I'm going to share with you. And also ASHRAE 62.1. Look at this. That is like a long list. It's a total what? I got the 18 pages. And leaving a nice, all equation stuff. Please read the ones and then at least understanding it. And then, when your commission agents talk about it, and then, oh yeah, you just throw the one answer, small things, you're talking each other, and then he'll know that you know. Then he's not going to bother you much. He's just going to say, okay, fine. And yeah. Anyway, that is yeah. So now, oh, the one thing that I have to go show the head on. So that's why I don't like that this PowerPoint. Come on, next. Oops. Don't step on my glasses. Okay. Once I will share, of course, I told you I share this file. So once you look at it, on each module, I call this, say module. Let's module. White one is what? White one is what?
Primitive.
Yeah, primitive. Primitive is what? We use other software tool to create embedded software module. So you cannot change it. And then the other, like orange, brown, whatever that is just logic. That you can go in there to view the logic and you can modify it whatever you want to do it. So some people say like, hey, I don't like this John Tem set point determination by Johnson control CCT primitive function. Fine, rid of it. Create your own. It doesn't matter. At least you know that which one is connected where. That's all. We're not against anything. A lot of people doesn't like that occupancy mode connect, determination too. Hey, I don't even have arc sensor. I don't even have a temperature arc sensor. Why do I, there's a lot of, space empty. Well, create your own. It doesn't matter. And then just like this, but once you create it, your own, you have to be validated. Make sure it works. When is occupancy schedule is occupied, make sure it's occupied. When is the occupancy override is overridden to another mode, make sure that is high priority override. Once that's working fine, then why not use that one? I'm not really don't care much about that. That's what module you're using it. It's all depend on programmer. Programmer has a right to change it. Why? Because hey, it seems like programmer think that maybe my knowledge, my logic, that when I put it into my knowledge into logic is working better, then use it. Because I told you, we made it up for like over nationwide, over worldwide. In Johnson control, we have to have somehow the one standard tool to let the user more than, 10,000, 20,000 tech to use it. So we have to make a CCT. But a CCT is not really fixed the tool. You can just replace with your own custom tool. Like some integrator. I met Wisconsin. I met Wisconsin last winter when it's a snow day. We had classes. One gentleman just asking me about so many things, and then he just actually asked me about his logic that he created. 80% of the thing he using 80% of his logic into main handle unit, mixed air single duct unit, and I was impressed. everything is damn working well. Even economizer. Guess what? He said he took the class when I had like a in branch side. He said he was our tech. And he said after that, he started, himself spending a couple hours of, during the, his own time to create those things, testing it. And then after, maybe after 5 years, whatever, that, all that lump sum, he said he ended up now that integrator, he actually owned that integrating company. And he just using that one. And then also he just share with his people. Surprised me, like, wow, I was really impressed. And he even, he actually programmed himself for the chiller plant too. So, yeah. So anyway, this is standard, but I change it here, there a little bit differences. So once you create your Q&A CAN program to answering same as I done, it might be slightly different. So now we're going to go back to this guy. See, this is my answer, Q&A. I answer this way, and you can follow same, and you can go to same, all the same. But inside, there is some slightly differences because I modify here, there a little bit to make, easy to understand it. But it's not much. Maybe, very hardly see it. So please, just compare it. And so I put the tag name with the VAV G36. So this is already applied at the ASHRAE new code G36 and 62.1. This is not, I didn't apply the California Title I because it's not a California. Who cares? Let them care about it. Okay, so, and once back to again, and just I'm going to just show that. See here, now, if you look at here, oh, sorry. If you look at here, there's the first two is AutoCal, and the next one is what? Demand limiting for the set point, demand limit set point hold for the G36 and so on, all this, like in order from top to bottom. I put in PowerPoints the same way. What is AutoCal? And then, I'll just detail this, put it in there. And then demand limit support hold is logic. So if you go inside, and now it's just maxed out, and then the same thing. And then in my PowerPoint file, I actually print out the PDF, and you will see this one. And then at least I got information some about what is the demand limiting. Demand limiting is what there's usually standard demand limiting in the boxes. There are no demand limiting, but if they go to some spec set, level 1, level 2, level 3, they want to specify different CFM set, whatever, then they are using that one. So I put the demand limiting, right this guy, state is right that one. And then when demand limiting is low demand limiting, that is a set point always come in here. But if demand limiting change from set point to level 1, no demand limiting to set any level 3, now they're going to just take over the last value, which is the last value. They're coming in. It doesn't matter set point change or not. They're staying at the last value. The last value future, this one, this block, last value float, last value Boolean, last value enumeration. This guy, this baby is a super high. I using a lot, last value, to avoid what? Internal loops. Yeah. Yeah, circular independency. Because CCT doesn't like the circular independency. Any program, all the Fortran. I started with the Fortran, 1980s. No, 1979. Once that the loop doesn't know when or how to get out, they're just stuck in there for just circulating it. But the last value, they put the same value, but they define the last value, throw that in to link that to that same value, but it is working. That's what is the last value. Last value is what? Holding value from last mode. If that mode changes, the last value won't change it. It'll stay at the last value. The mode changes and the new value coming in, but the last value will stay there. That is really easy. You can simulate it, create any block, and just test it. Last block, say you say on, off. When on, you put 20 degree. When off, 30. And then put down the last value, see what happens. You will understand easily. Oh, last value is maybe I can use very handy. Because the last value is good at what? Also safety. When system down, come back on, they stay at the last value, stay there, and then just come back on. Of course, please. For the main handle unit, please, any handle unit, just please, any unit, please use a power failure restart. Don't let the system to start right away. Because power on, controller start, logic, it's not safe. Especially for the chiller. Ugh. Okay, so this one is, I just, I kind of put, some explanation about each module, each logic. So, you can just see it. This is just for your reference, that's all. And then something that I put like a link. Why? I put the link, and you clicked at it, it'll just bring into the occupancy mode, determination and so on, that jumping around. So if you wanted it, I also can share that to this PowerPoint. So it doesn't matter. Okay, but let's just not use any more of that one. And let's go to the live one, the actual one. And a lot of asking about that the pressure requesting determination. What is that? I mentioned to you last time about the relation between box and air handler unit. This is it. Now, static pressure request is 0 and 1. 0 meaning is no need, 1 meaning is need. Meaning is what? I need more airflow. So if this is turned on to 1, they go to all their network output right here. Pressure require resource. You go double click it, and you see it. That is a Boolean point. The analog points, 1 or 0. Now like AV 25269. And then this MAC address right now 4, but it can be like, whatever MAC address. And then you can actually put that point into analog unit for P2P. Create analog input for like a VAV 101, pressure require. And then whatever how many VAV, doesn't matter, you put it in. And if they start changing to 1, and then say if that 1 is more than 10, whatever, then I'm going to raising up the static pressure. And then if they're all 0 or less than whatever the limit, then you're going to put the normal static pressure. You can do that. And this is what the pressure requested. Because a lot of people asking is like, hey, I see that the pressure request always popping up on the network output. What is that for? Oh yeah, that's it. And also here, now new, used to be, what was it, cooling demands or heating demands or whatever they require, but now they changed the G36 to make it nice. Set back and set up. What is that? Is a temperature up, temperature down. Those things. So, okay, and then what else? I'm going to just jump up around and just, kind of show you what is it. Also, people asking why using this module, which that is actually module is what? Is last value module. Why they using this one for the supply air area? because supply box area, we don't want to keep changing, right? Once that this is coming from where? Look at it, balancer override, right there. The balancer override is actually for, what did I told you? It is for the balancer. He can define it, he can change it whatever he wanted it. Once they change it, we don't want to just wait and until that he tell to us. We just let them just, changing it, and then automatically it'll send out the last value, and then it'll using that the calculation for the supply airflow. So we don't want to. That's what I'm saying. We are in business. We don't want to spend more time. Commission time has to be less and lesser for our benefit, right? Our pay is getting increased. But if we don't make it, we don't get the pay rate increase. So we always force to let the balancer do whatever he want to do it. And then all the values dump into here. And then you have to do only what? Back up. That's all. Just back up. Once you're done, all the backup, and then, to find, I usually put the folder, like, balancer, validation date folder, and then I put the VAV balancer validate date is like, whatever, like it's about 10, today is what, 10, 16, 12 to 3, whatever that folder. I put all the, a backup file into that, the CAP file into that folder. And then that I put store into the main drive in a company, and then just store in there, and then in future they can use that only that file. Meaning is what? Is validated, done it. So that's why we're using this one, because we don't want to sit there for like, hey, what your last value for the, your validation area, pick a gain. No, we don't want to do that. That's why it's like a damper, this one is like a damper stroke time. Yeah, you have to put it in, because it's, you have to put into the balancer override that make sure that some actuator like a 90 seconds, some of them is a 60 seconds, some is 120 seconds, whatever. You have to put it in the stroke time, because it's some guy somehow using the different actuator for one job and A job and B job differently, and then had a heck of a time to tuning, because the damper stroke time was different. One is like a 90 second, the other one is 140 second, whatever. So you have to make sure that the actuator, that's why I always look at the engineering drawing, and then look at the damper actuator. This is integrated one, it's okay, but I'm talking about this, like a mixed air damper things. Sometimes they're using incremental, but they are using different one. And then they have a heck of a time to tuning, and then I found out there was a stroke time is defined, differently. So, and then supply flow calculation, everybody know. Some, I see it like a very few, but some balancer didn't like that primitive equation. As he says, like, why don't you guys using just a standard equation so I can see it? Okay, fine. You can just create your own and just link to all this output correctly. That's all. Yeah, I saw it as some very picky commission agent, especially ex-Johnson guy. They really, every time they come to my job, they start kind of teasing around and then try to make a hard time, but it's okay. They can do that. They have a right to do it. So, supply pickup gain, that's the 100%. Depend on the balancer. Do not ever change yourself. Do not. I'm telling you, area, stroke time, you can change it because you know. Because each box is a schedule, box schedule. We know all the area and stuff. And we know that initial even pickup gain, they usually some mechanical engineers, they are nicely calculated and put it in. Then we can put those things. But once that hand on to the validation phase. If the commission agents guy come in and he start changing it, after that, don't change it. If you change it, the warranty, everything fall into your head. That's it. So please do not change it. And then, especially supply pickup gain. This is a strictly balance calculated, and he put it in. So we have to just make sure the record is, because he actually, the balance has to be provide us that spreadsheet for all the box data. So, he is, I don't know how they work out, but usually when I was branching my operation, I always, not encourage it, mandatorily that all my tech to collect that spreadsheet from the balancer. If they don't give it to us, then all the warranty issue, all the issue, it go into the balancer. I'm always going to threaten too. If they threaten me, I'll threaten them. Like, you're not sharing it, and then why? Some balancers really, they hate to give it to us because you know why? Because maybe he worked some slack, some here, there. We have to get it. How are you going to prove that the customer that it's not my fault? So that's why, please ask them balance the report, copy of a balance report. They maybe give it to the customer, end user, project owner, maybe not to you, but you have obligation to have that one. And then next one, the temperature set point offset. That's a new one. That's for the G36. Usually we have a temperature set point determination for the standard, regular standard one. But now we have a temperature set point offset. Well, look at here. What they printed, what they put it in there, the future. Window open cooling, window open heating. Yeah, they put those things. Well, that makes sense. Some buildings, they are indoor air quality. Some buildings still have like window open and close future things. So, old mechanical style. And so when window open, cooling set point will be raising up to 120 because we don't want to pushing down the cold air, wasting money for the chiller. Think about a chill water pump, air handler unit. Well, everything is costing. Everything is money. Flow out, outside the window. Window open heating set point is 40 degrees. In winter, when some people window open, the heating is pumping in. That is all waste money. That's what the G36 is. ASHRAE guys thought, everybody know. But nowadays they're like, oh, this is smart idea. We're going to put the article. We're going to put the in an article. Make sure everybody have to follow it. That's the ASHRAE. Common sense, but they put on the paper. That's the rule. But we already know these things, isn't it? I mean, during the summer, if somebody opened the door, we don't want to pumping in the cold air into that area. But used to be, do we have any action? We never. That's why these guys put it in, and then they put the article nicely. Oh, the new ASHRAE G36 is saving tons of money to the building owner. True. That's why they put this one in. Demand limiting offset. Demand limiting 1, 2, 3 level. Demand limit level. 1 degree up, 2 degree up, 4 degree up. They just kind of different offset. And this one you have to wait until that actual seat from the spec. If they say, okay, I want to using window open, close, cooling set points, this and so on, and then they have to provide the hardware input, window open and close the status contact points. That's right there. Then if they said, okay, using that from the input, and then you have to throw that the hardware input, and then just link that one to here. And then they said, oh, window open cooling set point, we want to using 100 degrees, then you have to change that value. So anything capital, it is that exposed. So they can change it from that, supervised devices, whatever. This one, same thing. So it's up to them. We don't have to worry about it. And standby offset is 1 degree, so on. So if from the outside, just the connection is, we understand it. And then inside, you can see really how they done it. Just whatever I kind of described to you, this is the logic too. That description, we put the logic, that one right there. So just to follow. Oh yeah, the mention that I told you that I kind of touching here there to let you guys to understand easily. Let's just like this. Timer, standard program will say timer up delay, but I put at least 60 seconds, 300 seconds, and those things, so you can easily understand it. And yeah, this is just logic. So we're using MUX enumeration mode. That enumeration mode, each mode will define into 4 different modes. And then 4 different modes will have a separate 4 different analog input value. That's the MUX enumeration to float output, right? MUX is a very nice feature. Instead of using hierarchy state table, I try not to using much hierarchy state, because the hierarchy state is sometimes like complex. When they go up to like input is more than 5, then it's going to be a nightmare. If you not choose right, I mean, input is Boolean is fine, but input is the enumeration, several different states, it's getting more confused. But the MUX is easy. Your demand limit has like what? 4 different mod. Each mod, now we can define 1, 2, 3, 4, and then when mode A, no demand, okay, send out, whatever that the default the input 1. When level 2 or level 1, then whatever that level 2 level 1 offset, those things. That means like the same way, the set point. You can use their set points. Sometimes like this is not VAB, but let's say something else. I say water temperature. Somewhere in winter, you can make like a somewhere in winter for enumeration, right? You can make a somewhere in winter enumeration. And then somewhere in input enumeration, and then input 1 is a summer, input 2 is winter, defined it. And then you can link that or some more input at the input 1, winter set point at input 2, and then you can just link out to that actual effective set point. That's fine. And pressure, same thing. Pressure require Boolean. I mean, it's like that. That is maybe go to the Boolean mode to the float output. And when pressure require, then you can say that the pressure require. Then you can set pressure require and then not require set point differently. That's the MUX. So use a lot of MUX, please. Testing aloud yourself too. Like it's same thing. You can make like just multiple. You can create your own MUX. Say, oh, I have a 10 different mode state. Fine. You can create 10 0 to 9 state, the future one. I mean the state one, enumeration table, and then just put all the you throw the total 10 input, and then you can just define all 10 input differently. So MUX is very powerful. MUX, Boolean mode to float, Boolean mode to Boolean. You can just use it all combination. And I like the MUX. And that's why I say like, oh yeah, this MIT group guys, those guys are really smart. Otherwise, just how could I have thought about it? That's why I adopted this feature to the EGIO. So now EGIO has the same feature. So now that's my customer really liked it, because instead of they're using all different logic, now I got a MUX table, they get connected it, done with it. See here how many are using his MUX enumeration out here, 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 here. So when window open and close, window open here, window close here, whatever, you know, those things. Set point differently. So this is it. This is inside. And whenever you're not sure from that the CAN program, what are you going to do? Simulate it right away. Simulate it, and then just answer whatever. I don't care. You know, don't define any answer. Just say yes. And then for this logic, you can come and start commanding for each block yourself, and you can test it. See it is really working. Don't just put everything into the real flow, and because when you're asking simulate it, they're asking this, isn't it? Right here, this table. Don't try to answer it. Just forget it. Just start simulating. Once you start simulating, it'll take time because it's just complicated one because the G36 is so it's more. Simulation is all count at every object. Every object is what? Point and line and module. Even line, they count one object. So if that object is exceeding certain limit, then simulation will not executing it. But VAV never done it. But handler unit, chiller plant, there can be. So anyway, this is now you can go in there. You can actually commanding yourself. So right now, window open, close, and the demand limit is now no demand. You can just say command. I want to go with level 1. Now level no demand, so it'll now go to 0. But I said, oh, now level 1, boom. And it'll take the 1. You can test it yourself. You can test it individually. You can change all that value, make sure that it's working correct. That is validation, testing your own logic. Because you put all nice, logic, but you have to make sure that it is working. To how to check simulation. So simulation is very handy. I really appreciate that they put the simulation feature in CCT. Because EGIO or the other, I see like, PLC. PLC has like sometimes a simulation logic, as they do mostly. But so we can see all the ladder logic. I can see that the lights are on and off and so on. So that's why we adopting from the PLC and this feature simulation, so we can tell it is working right. And once this is all validated, think about it. Now, once you validate it, testing it, and then each individual logic is working fine, and then you can go there and actually what I done first time that they simulate it and then put the actual value into all those points and then tested it from the whole function in a whole CAD file. Make sure it's working. So, and then another new one, VAV, minimum occupancy flow calculation for G36, ASHRAE standard 62.1. Boy, this is, I don't even, we usually have what? VAV minimum flow, and then VAV minimum flow reset by CO2, right? But now G36 is different, slightly different. So now like a VBZ-A, what the hell is that? Personally, I'm telling you that the first time I look at the G36 feature in a CCT, I start digging into the website. What is it? And then actually, guess what? I tried to full understand about the G36 and 62.1. I went to log into the ASHRAE. Link into ASHRAE. Guess what? They want to buy for the documents. They want to buy it, $120-some. Forget it. Anyway, don't worry about that. I got G36 right here. Did I put that one in? Let me just check. Not this one. F-ray 26. Yeah, right here. So I done my job a little bit. So try to let you guys easily understand it. I kind of link all over the place to find the documentation. So I'm sharing with you. VVZ is what? Breathing zone outdoor airflow. What the? Yeah, it took me for a while to find out. So then after that, I read this article. I said, oh, yeah, I understand it. We are really slightly different using different termination. I mean, just abbreviation. But once you read this article, you'll understand it. Yeah, VVZ. I was like, what in the world is a VVZ? And like, oh, breathing zone ventilation. Actually, that's kind of backward, but just like that's the one. So anyway, I put that in there, especially in my PowerPoints. I did my job. Oh my God. Pressure G36, right here. Is this one? No. Minimum occupancy. Minimum occupancy is what? Where is it? Hold on, let me just go back again. Temperature set point after that. Okay. Right here. Okay, yeah, right here. And then I put like here. Breathing zone out there flow for zone flow area. Default is zone. And the VVP is a breathing zone out there flow for the zone population. How many people's in that room? This is, I'm telling you that the ASHRAE, they done nice. This is really, I don't have any obligation, I mean, just object that is like, they done nice because they want to make sure that conference room, sometimes we see what? I was actually trying to build that the occupancy sensor. They already have it now, a third party. I mean, Mitsubishi, they use, was it Mitsubishi or was? No, it was a Panasonic. They, about 3-4 years ago, I was working with them as developing some future for this occupancy, determination, how many people's in the conference room. Because it's conference room, we have a conference room. Conference A, B, this room is a 20 people capacity, this one is a 50 people capacity. And then, the VV box is just a sizing with that and then dump there and so on. But sometimes that the room can be a less capacity, and we don't want to pump that the design flow for that the maximum flow, maximum capacity. That's why I was focusing to, before they talking about the way G36 was 62.1, I was like working with a Panasonic that, hey, how about you guys have an occupancy sensor that can determine how many people's in the room to link into our Metasys system. And then we tested it, it worked it, we were excited. And then actually the company turned down because it's, hey, actually they don't care, so why we care? But see, after what, 4 years, boom, now they care. And then now company come back and say, oh, no, by the way, is that still live? I said, yeah, it is. So we are now come back with that, my development for the occupancy sensor, because it detects how many people's inside room. So that detection that I can tell that bring down the CFM set point or bring up and down the CFM. That is what? Energy saving. Big energy saving. Think about it, it's like an insurance company, insurance headquarters. They have every time I go in, like American Family Insurance Company, headquarters in Madison, Wisconsin. They have I cannot even remember how many conference rooms they do have it. They have tons of a conference room. And then there are always people in and out because the insurance company, they always, try teaching the people. That's before pandemic. Now after pandemic, everything is online. but still now they're coming back to now, just, face to face. So that whole campus, after they apply that number of people inside the conference room, we actually applied that the Panasonic, that occupancy population sensor, applied it for the demo. We didn't charge them. I just select the 5 conference room, the largest one, and applied it. They loved it. They want to apply it to every single conference room, even office, an individual office. 1 man, when they're standing there, they want to put the minimum CFM. 2 men, they want to increase up, and so on. So that project, I don't know, still live or not, but after I kind of get away from the branch operation, now it's hopefully up to them, so they go figure it out. So anyway, so CO2 rate limit is still there same. So everything is combined now one. Used to be minimum airflow initial set point, and then next is by the CO2. But this is G36, everything in combined. They also care about ventilation requirement of that by the floor, the area, plus get the number of the people inside. So good. That is a new one. But see, easy, isn't it? Once you understand, I mean, listening it, and if you look at least one article, you will understand it. Now the commission agent come out, you can just throw it out the question. Hey, what about that minimum flow for the G36? Let's see that he's ambitious or not. Test it. Oh yeah, don't test it when he was in a good mood. But if he give you the hard time, just throw it out, just like a joke. So window open, see that right there, window open status. You have to have a hardware input, and a Vmin, ventilation minimum, so auto Vmin and those things. EGC. That is another one. That is EGC is, what is that for? Like effective zone cooling. EGH is effective zone, zone for the heating and those things. So this is slightly advanced resetting that the set point, but it makes sense. So it's all there. So please just, read, just like, if you're not seeing it, you don't have to worry about it. But if you start seeing the G36, just using this reference, that's all. And then I put down all the red object name. That is for the output side. Anything in the logic is output side here. All the red meaning is right on the left, right side output. So I kind of split out so you easily understand it. And zone set point determination is nothing changes. I put, usually when default CAM program, they don't give this remote zone set point mode. So I usually create my own. Because some campus, some customer, they require, hey, we don't want flow people to change the set point, then I just select the network only. How to do that is right there. You have to put it in enumeration. It's right here. Remote, this guy, right here. Remote zone set point. I added this one for the enumeration input, and then I put zone T remote set point mode. It'll come out this 4 selection choice. Right now, default is hardware only, typically. But if you go to a bigger campus, and they will sometimes asking, hey, we don't want them given to any choice for dialing that set point. Then you have to select that the network input only. And then people still can dial it, but it's not going to do anything. Yeah. That is, I see a lot of that happening, especially in the hospital. They don't want to give to any right to changing that set point, because that in a code for the violation for the virus and so on. Now these days more kind of tougher and tougher and then more strict. So they said they don't want to change anything by the floor people, only by that central station, central monitoring station. That's all. That time. Using the network input, the state 3, state 3. And then sometimes like, oh well, we give them a state 4 option when network input is kind of offline, then they can go hardware output, but I never see that happen. Just, there are two choices. Network only, hardware only, that's it. So. And sometimes if like an end user, if you have if you have a face with the really end user, you can just recommend that. You have several choices. You want the people to changing set point, or you don't want them to changing set point. You can just kind of nicely recommend it. So that's the Jones set point. And then other than here's also I just adding that network GNT set point. Usually John's control branches they're using, because we are using on the hardware GNSP, right? Yeah, GNSP, but the Johnson control branches you are using for the network input, not the NW. I using the NW, network joint, because it's easy to understand. But John's control standard for the network input for the zone temp is a GNT-SP, and the hardware is a GN-SP. Mostly, I got always kind of a feedback from the end user that is, hey, why are you guys using, can you just put the NW inside, front side, whatever, somewhere? So they easily understand it. I said, oh, well, you can use it. It's up to them. But like University of Wisconsin, they have a standard object name. They just give to all Johnson, any controller vendor that they go into University of Wisconsin campus in a state of Wisconsin, they have to use that name, object name, no matter what. VAV, they have their own name. 800 unit, they have a own name. They just define every detail. You know why? Because it's all University of Wisconsin, they have their own team, that the VAS team. They are 100% ex-Johnson guy. And they hate Johnson. I understand it, because it's, just like, they're not hated. They just kind of make it tease you out, just testing you out. But these guys are really all senior, they are all system engineer level. So they kind of sometimes poking around at the new tech, like, come here, you know this? And then they just like, new techs are like, oh, no, I don't. But good thing is they teaching also our tech too, so very nice. But this is a state, this is a set point. As you see, it is all, just internal set point, plus that some miscellaneous like gain and stroke time and those things. The next is real fun come up, is a state generation. In the state generation, they're always asking, first of all, no matter what, any program, there is a water system flush pass-through. And people say, like, why are they using that value, the LV value? Because same thing, we don't want to using the LV value because we don't want to lose any chance that last holding command. This one is coming from the system mode determination. And system mode determination is coming from where? Is sometimes you can just click that one, and then you just bring into that module. See? You don't even know where's this system module, just double click it. And then it'll just bring into here. So this system mod, this guy right from here, and system mod has, just like occupancy schedule. Sometimes, like, massively from the central station, they can command it for the all boxes, go to the cool only, all box go to heat only, fan only, water flush, purge, auto. Auto is just, but like a water flush, why? When they're testing the chiller side, a water flush and water balancing, they want to open up all the valve, right? Or hot water pumps, balancing. Usually pump balancing. They want to open up, then you have to command it to the state 4 for water flush, and then every valve will be open up. Because that's easy, isn't it? Go one by one. How are you going to do it? But if they can go system mode, select all, in the network table, Taylor summary, you can select all boxes for system mode and command once. Override to water flush. Then every box is that command, it will be open up. So then water balancer, they can balancing it. They're going pushing up the 100% pump speed, and they just have to be calculate themselves, make sure that what is the gain and so on to themselves, their equation. So that's good for that. And then purging. Well, when they're using purging, I mean VV box is not much, but they are using once in a while. They're purging it to all the purging out that all the. I never see that happen. I really never see that the purging that the whole entire box at once.
I used it with test and balance.
Oh, yeah?
When they want
Oh,
to
they
check
want.
the CFM on the air handler, I used to, well, it was before in the old version of the utility tool,
Mm-hmm.
send all the boxes to purge.
Okay, good.
So that you could check max airflow on
All right.
the air handler.
That's good. Yeah. Just see, it's right there. So when they're testing out that air balancing, for the main handler unit, opening up all the boxes, and then you don't want to go one by one from the central station, gathering all the boxes, for the system mode, commanding to the state 5, they're purging it. Then it'll purge it.
It doesn't, from what I saw, it doesn't just open the boxes. It
Yeah.
runs them to the max CFM.
Right, max
Whatever
CFM.
max
Yeah.
CFM,
Just the cooling max CFM. So yeah. So when we talk about the box max flow, is always cooling max flow. That's defined by mechanical schedule. The schedule has it, so it'll just open up the box to maximum flow. But so it is either way, but just like sometimes some customer, they just selecting all the box output command, a box output object, they overrode to the 100%. And so, well, it doesn't matter, but just like to me, that is like, purging is more easier. But even some customers, some branches, they honestly, a lot of people does not understanding of each individual feature. So what they do is they just override the boxes, override the valve. That's it. So, but you can explain to them nicely. Because it's overriding 100%, meaning is sometimes it's not a balancing value. As the gentleman said, it's like purging is actually bring out to the design maximum flow. Design maximum flow, maybe damper have to be only open up to the 85%. Sometimes, maybe 100% is way too high. That's not actually design the balancing. It's not the balancing for the design flow. So design flow have to have to use at the purge mode. So you have to be just knowing yourself. Also, when the balance asking for it, you have to be execute that correct mode. Don't use that to open up that box 100, override 100%. Don't ever do that. Because you're going to ruin up the whole airflow balancing. And then PID tuning reset. Are you guys doing the PID tuning reset for the auto tuning reset or something like that? I mean, just like schedule tuning reset for the boxes. I mean, everybody using auto pit loop, right?
I had to do it for an air handler one time.
Oh yeah.
They had I forget, it was like a stage of cooling or something wasn't working for so long
Uh-huh.
that it just threw it all out of whack. So
Yes.
once they repaired that stage of cooling, it just wouldn't control the
Yep.
discharge air until I did it.
Right.
To the reset. Yeah.
Good. See, that auto PID tuning is like a PID is what? That's PID is a calculation. Actually, D, forget about D. Deviation, in control, we're not even using it. PI, proportional and integrate. That's the only two mode that we are using it. The D is, if you start using D, you have to really careful about the timing it, and then it'll go like a nightmare. I'm using D only when it's really I face with pump speed control. Prices, pump control. But I only done maybe less than 10 times in whole my career in facing with the CCT PID side. Anyway, the PID is, we are using auto tuning, so it'll just calculate all the time. It's fine. If there is no outside disturbance, the PID loop is fine. But suddenly when power outages, something, boundary shut down, back on, and then that PID loop error, that the error calculation, delta error will be increased, and then it'll just swing it, stop. It'll take time, but it'll come back. But customer can asking you, hey, one time that handling was crazy. And you can ask him when it happened. Maybe after power outage, after somebody doing service, when they, instead of shutting down, they just cut down the power, boom, and then changing some belt or some, whatever they work, service on the, VFD, whatever, that can be happen. Or changing motor. Then delta error will be just increase like this, right? If you kick back on, it'll just, the last, delta error was this much, and it went back on, put the power back on, VFD, woo, it'll go to like, error delta start going increase, and then output is what? Oh, with that cover up, they're gonna start swinging, like, they're gonna shooting out, coming down like this. So it'll just, maybe for 5 minutes, they swing up and down, and the customer will be freaked out, right? Hey, your system is go hell. You gotta come out and fix it. Then ask, to please, to tell them. So whenever you do it, you executing the handle unit, especially, just educate that end user. When you shut down, please shut down from the commanding to off, override off, whatever. Don't just power down, but they still the power down. But once they power down, or you can just ask gently, that asking that reset the PID tuning reset. And University of Chicago Medical Center, the new building, that is, we put the 4,500 VAV boxes, and we actually executing PID tuning reset every midnight not by once. We actually phase out, so group 10 each boxes, they start with auto tuning for 5 seconds. And then open, from the midnight, right after midnight to 4 o'clock in the morning, we just kind of calculate it and split out. So make sure that the handle unit not go crazy, because the medical center building is always 24 hours running the unit. So we don't want to swing like at midnight like a crazy, and then patient will be get kind of scared to hell. It can be. So PID tuning is that. And auto calibration, boxes, when they start time pass by, the damper stroke, they start kind of a little bit kind of upset, errors get maybe the travel distances, angle can be changed slightly, and then calculation can be default, right? So we have to do the auto cal. Auto cal is the same thing. That just like a PIDs, the ideas, hey, when they're going to be calibrated. We are typically recommending that every 2 weeks, 14 days. You can go there. You can change it every 7 days or every 10 days. You can change it. It's not a backnet exposed value, so you have to go in there, change it yourself. And then if a customer asking, oh, we want to change an auto cal every month, then put the analog network input right there, auto cal duration, whatever, name it, and then let expose to the network side, so end user can change it themselves. Don't change yourself, just let them change it. But anyway, default is a 14 day, and so every 14 day, it'll just auto cal will be reset. Boom. And yeah, AutoCal, but right now here, AutoCal request is from the also balance override. So, but if they said, oh, we don't want it, they can lock it, then you don't have to do it. But if they are required, then you have to be the AutoCal. Usually AutoCal used to be old pneumatic system. We have like a solenoid valve to trigger that the solenoid valve to auto-calibrating that actually a DP sensors. But now that still a lot of people, a lot of places, they're still using it. A lot of places, they're still using solenoid valve to AutoCal. So AutoCal is really, I say this is really a key point for that maintaining long-term over VAV boxes. I'm telling you, after 1 year, you measure it, the DP, recalculate it, it can be different if you don't do AutoCal. AutoCal is actually resetting 0%, resetting 100% right now. But after 10 years, after say 5 years, resetting 0 and resetting 100, that distance can be different because it's worn out, whatever, dusting inside. Is there any? How many end user has been you see that the cleaning ductwork? Oh, bye. I have a good experience that the one is in an animal lab in a, what was it, UW Madison or someplace. And we had like a flow station, flow stations, and then, Aptron flow stations, and then, they said, oh, CFM, supply CFM is always not accurate. It's not shooting out the more than what it's not shooting out what the design value is. So I said, oh, well, we provided the, Aptron station, so we actually bring out the mechanic to pull out. Guess what? We just move a little bit, and we put it back. And then we just open up the other side, take the picture, and give it to the customer. It's not a dirty. It just clogged it. It's like dust and the wet, because the moisture come down, the humidifier. It just bundle up, and you cannot even see it anymore with the probe. You see just big cotton ball type things all over. So, but it is. They don't clean up. They don't. Why? Because the filter, they depend on the filter. Is a filter really 100% they cleaning up? What? If they regularly changing it, yes. But what's the cost of the filter? So some medical center, they start to change it to the DP sensor to another unit side. They changing to DP instead of contact. They changing now your analog analog transmitter, right? Expensive one, because they want to see the actual pressure. That's the better.
Should the air source be off for when you're doing an auto calibrate? Like if you had that network point.
Yeah, that's what I'm saying. No, you don't.
Turn
It doesn't.
the air source off or no?
No, it's not. That's why I say you have to group it. This one, same thing. You have to group it too. You don't want to do at one set right away. So you have to make a kind of modify this one. How? That is like a balancer override right there. Here it is. On the balancer override, there is AutoCal now right here. AutoCal now LV. Write this guy. Take the AutoCal sequence right here. But anyway, that AutoCal, you have to modify slightly different way to AutoCal command. So give a different time, so like grouping it. Otherwise, yeah, the main resource is going to go crazy. But without that, the main source, it's useless because it doesn't take it reading the right CFM. I mean, without the main handle unit, just like they don't know what is it.
I guess I just thought it would work if you like say the air handler went on-off, then do it like say every night when it went on-off, then it would, because it is still a network input point, right?
Right, yeah.
Okay, yeah, then you could toggle that.
Yeah.
Then it would see 0, but you could never do the plus side of that, but I guess I was just.
Yeah, all right. Yeah, whenever you do, especially that auto cal or pit tuning, make sure your resource is live. Otherwise, it's useless. But when you do it, also you have to be careful that make sure it's not in during the regular time. it can be hiccup. Or some people can very sensitive, you know, like, you know, why my air, why I hear some weird sounds. My diffuser start giving us, you know, weird sounds like a speed and noise and stuff. So that's why we always recommending after hours. Yeah. We're not only just, you know, facing with, you know, this programming and technology, we are facing with the human psychology too. So we have to be really careful what we're doing.
Is that auto-calibrate done by stroke time?
Yes, yes. So that's why it's like the stroke time is really critical. So right now it's like that stroke time also coming from that, see, as you see that the stroke time, supply damper stroke time right there. And that is actually, yeah. Yeah, and then that is a link from the balance override too. So balancer, you know, will.
You need to change that, you need to start from the balancer over.
Yeah, you have to define the, you know, when you don't, you have to define the when you program it. When you program it, you have to know exactly what type of actuator is it. Usually, you know, integral, this is integrated, VAV, CVM is integrated, 122nd, you know, that's the integrated one. But if you, sometimes you have to use maybe some other actuator, somehow, whatever, if that case is, you have to know exactly stroke time is. Yeah.
We've had problems with like a 45-degree damper as opposed to 90.
Yeah. So some stroke time is 90 seconds, some is 120 seconds. And then, like if you're working start with some lab area, they are still using a faster one. Apptronic one is 3 seconds. So, yeah, but do you think that they don't use? They are using now.
Yeah.
For the old chemistry building lab area, they are using now. But we are now supplying, that's why new one that we are using now is like our Tritech Fumud valve. That is also, I actually designed that, programmed it. We are selling with CVM. And then I'm now working with EGIO. So Johnson branches side, our OEM brand people and then integrator, they are using ABC channel. They can sell with F4 and then or M4. And then non-Johnson, you know, external side, we are providing with EGIO. So same thing. Is a stroke time. Actually, I have not a stroke time. Sorry, stroke time is 1 second, but control has to be in 3 seconds. So it's working now, and that is actually, it's not a CVM. It's a CGE. It's different one. It's yeah, CGM. What you got now? That one. But we put the special processor inside, so it's a faster calculation. So 1,000th of, you know, second sampling time. So it'll just, you know, fastest, you know, controlling. So I can control any changes, you know, offset. If door open, and then, you know, that changing, you know, we have to put the all the what negative pressure in that lab area, because the positive, I mean, is going out to, you know, corridor, and then it can be kill people. So we have to be just make sure that they're all negative. It's got, right now I can control within 1.2 seconds. So it was a challenge. I worked over a year. It's not with the program, it is a mechanicalism. So, but now finally we defined it. Now we are selling that the Tritech. You will see it someday, that if you see a project with a Fumud, you will see it sometimes. You see that the CGE, that is a different one. So same model, same black, same white. F4 is white, and M4 is a black. That's same, exactly shape, but only difference is inside the one chip, that's all. All right, yeah, let's take a break, 10 minutes, and then we can come back. Yep. why we are using FSM? And I said, like, oh, well, we try to minimize that, logic or capacity of that processors, because we cannot handle. I mean, unlimited way, no, we cannot handle that. So we have to be minimize all the feature. But we are not only this CCT CAN program. It's not for just the one type, because we program this one for multiple different types of the equipment. That's why we are using FSM. So that's all. Nothing else. AutoCal is using not only VAV. We are using also in all other different way, and even air handling unit. You can use that AutoCal to calibrating that your DP sensor and so on. But do we need it? Is up to spec. So yeah, is it this? I put in the PowerPoint spreadsheets that all explanation. What is that? So just read it. Just. And also what I missed it is like for the AutoCal here, right here. This is AutoCal exposed to the backnet. Tell that customer that you can maybe you guys actually do the head end side, the Jace's side. Okay, then just make a schedule for the AutoCal and tell them that how duration they want to spread out for the each zone and so on. Don't AutoCal for by once, just joining out by scheduling it. So you can just help them, guiding them, so they can do themselves whatever they wanted. Sometimes some customer they want to do while in their working hours, but they don't want to execute some feature during the unoccupied hours, unattending hours, because they are scared. So especially hospital, and then some lab, involving lab area, they always want to make sure they do while they are in the building. So they usually do it right before the business hours done. So like 4 or 5 they doing it. So it's up to them. But you have to recommend it. So yeah, AutoCal. So this is they can group it. They can group it and then tell them don't do by once. Just group it. Make sure they're like a $10 per, maybe time duration, like a 15-minute differences, whatever. So okay. And biggest fun is right here, balance override. So, but you have to know exactly what is the balance override or what feature the balancer can change it is. Like he can change it, just like a supply flow and so on. But here's what the hell is the unused flow 2 and then flow X and so on. I mean flow. This is for like if you're using like the flow. Box with the exhaust fan, the supply and exhaust. The one, some simple lab, they are using this way. In especially a hospital, some not surgical area, but even surgical area, they are corridor area, they are using supply and exhaust. So at that case, they are using this one. But when you Q&A, they will ask what type of exhaust box is that apply or not. A standard, usually we don't, but if they do, then you have to select it, and then they'll calculate right there, and then they start using the offset to make sure that the exhaust box is not opening too much because it's based on the offset. So, and all rest out the output side, we know that is like this is output go out to the calculation for the supply flow and area and K factor. But cooling max, cooling mean, and all this one. Please make sure that you put the design from that box schedule, because it's we used to have like before, I think it's before. Generation 10, revision 10, we used to have like a point schedule that we can, using the spreadsheet to massively download or changing all the K factor area and so on, and we can massively download it. But now since that the new ones came up, then we don't have that anymore. But we do have like a Taylor summary, so you can use that one. But especially box side, I told you that any balancer side, don't mess around. Only you have to, you can just adding, you can do initially doing just adding value based on the room schedule. That's all, in mechanical drawing. Other than that, don't touch it. Let the balancer to do it. That's his job. If you do work for him, then he'll be saving time. He'll have more bugging you. And then box flow test. This is a box flow test. Once the box flow test is like AutoCAD executed it, it'll go start doing the box flow test to make sure that DP, whatever the receiving DP is a flow calculation right, and then their DP offset, it'll be just a step point. They're testing that way, so just make sure that the damper is correctly sending out the CFM based on the DP reading. So that's another feature, but so you don't have to do anything. Just but you can just testing it. That's all. Once there's the power cycle, it'll do always whenever the system starts. First thing is they'll do the box test, flow test, no matter what. So you recycle it, it'll do that. That reset the box flow test cycle has to be expired. So you have to you initiated it. You downloaded it, you power on, started it, and then you don't see much change it. Why? Because it's still testing the boxes. After this done, usually the stroke time, and then it'll start go to the actual flow for the whole logic. Those things, all these one, actually, if I connect and show all, now if you individually select it, it'll show that the individual connection. But if you select the show all, the first top side, this is a state selection. This left side, that is a priority. Water system flush. Water flush is priority 1. If water flush true, they don't care about all the bottom sequence. It'll take this one as the first. And then right side one is, I told you, that is output control. So based on that priority level, this guy will do whatever they're supposed to assign it. So that's on the show all, but if you select the state table, the left side, whatever we saw right before, the left side connection, that's the same order. Top to left, top to bottom, priority. Priority 1. So this is all connected from where? Connected from state generation in the middle column. On this one is the output control. So when water flow sheets go to true, box heating set point reset, who cares? And then box heating control, valve control, oh yeah, we want to open valve wide open. And then supplemental heating side, yeah, we want to open that too, wide open. If there's a fin tube or radiator, valve, they want to open up. And then rest, the supply damper control, set point control, we don't care because we are only water flush, you only care that heating source valve. That's it, right? That's it. So. And then PID tuning. Once that the PID tuning, now the box water flow is now false, but then if your PID tuning is go true, then we want to set up we want to hold for all the calculation. So this guy, the set point control and so on, we want to hold it. Hold the meaning is what? Don't calculate anymore. Stay as it now. Because we are now clean out that all the error, all the DTs, whatever the value calculated, that the calculated value or store the value, we're going to clean out, purging out. So PID loop is now fresh and clean and started again. And that is only what? How long it'll take it is only like 10 seconds. That's it, maximum. 5 seconds, actually 5 seconds. If you have like a PID tuning reset, and you will see the PID first reset, PID second reset, and third and whatever, that is only 5 second duration, that's all. So that once they're done, and then they'll just, so when you commanded it to PID tuning go true, that true is a stay right there until that you go set the false, but it's only do the what? One shot type. Just go there, one shot, and after expire that internal duration, then it'll expire and go to now next. So auto calibration, same thing. Auto calibration, we don't care about the heating side and valve side. We only care about the damper control. So auto calibration, we are only calibrate the damper. That's all. So state table, this is the beauty of the CCT. You can design your priority, and also you can create your output control, and then you can just select the different control option on each individual control module. And once you start understanding the state table, you're understanding fully 100% CCT. This is core. This is a CCT core. So when you start the simulating, you will see the changing, the light, the color actually, the green is actually that now that position is at. So you follow the green, and then you will see it. So you can change from the simulation, you can change the condition on the priority, and then you will see what it does, each individual control module does. And we're gonna do this one is keep doing for until Wednesday, because I want you guys fully understand the state table. If you don't any question, raise hand, just to start it. You can just stop me anytime on the state table. This is core. This is core. You adding now, say, oh, I want to adding one more, like I told you, we can just put in a side loop. We can adding side loop. And we can adding side loop to, on the priority, any places, whatever you wanted it. And then you can create another output control module here, whatever on and off, or mix, max, or whatever. I don't care how many state it is. You can put another column here. You can change it based on all this priority also. You can relate with it. This is power of the CCT. CCT is not really concerning about how to logic program thing, because logic programs, everybody can be different. If I ask you guys to create, okay, I want you to create the logic for determine the set point for roof set point based on the heating, cooling, or winter and summer, and then the fall, whatever, full season. All you guys can program different way, but result is all same. That's what I'm not really worried about that, but I'm really focused on to the state table. This is the beauty. I handle the stack program. I handle Honeywell. I handle Siemens. I handle PLC, SCADA, DCS, but I like this feature, state table. I wish this one has even easy I/O. I am working on it. If I can work out, maybe take for a while, maybe 1-2 years, if I can done, then I can sell more easy I/O, maybe easier, as name as easier. Right now, people say it's like easy I/O. It's not easy because it doesn't have much choice. You have to create every scenario. But this one, you don't have to create every scenario, because you just create the priority and do the determine the logic mod. That's all you need. But think about it. Say this one is not bad, but let's go down bottom here. Okay, now I am at the say box heating, and then all this. If you have like this 5 module, and then you try create all these feature without this table, the file size is going to be what? It's going to be a nightmare. You cannot even follow yourself. This is beauty. I have, what is it? I have another controller, is non-Johnson, and I try to kind of break down their way to done it, because I've one of the customer want to replace with our controller, and then they don't share that their resource, how they done it. So I had to reverse engineering it. And then I found out that they don't have these features, so what they done is they just create the logic. I mean, I open up and I was like, oh, I close down, I don't care, I just erase it. It's like, I ask customer, what do you want to do? I just asking them, and then they give me the their sequence of operation, and I created it. Because it's without this, it's gonna be a really you're gonna see maybe more than 200, 300 line and the block linked together and so on. Not only one logic, you may have the couple logic, 1, 3. You may need each logic block for whole this, for every single output module. So this is beauty. And then once you understanding this one, and now you will understanding how they relation with this one, and then you will understand all this. Because once you go into there, this individual one, which they're coming from the state table link output module, now you will understand what is this mod meaning is. This is coming from where? The state table. See here? Off, hold, heating, discharge, and reset. That mode selection is actually come from the state model. You do off or hold or heating, discharge, or reset based on priority level on state table. And if you not follow the state table, then you wouldn't kind of a troubleshoot. So now this one is like for this one is a box discharge at tempo reset. So we go back again and state table. I go down. So the first column, box heating discharge at temperature reset. So here, let's say, satisfy. When you satisfy, we want to cut off there, right? When is what? When is box heating and supplemental heating? We want to hold right there, it's second state, right? And then when is the box heating or supplemental heating, we want to go discharge and reset, heating, discharge, and reset, because we are now in heating mode. So there's all three modes is right there. That these priority, individual priority, will just determine what mode you are in control output. This is simple, but let's go to supply flow set point. The last column one. Supply flow set point for the HA file. See how many more? How many more? A lot. And think about it. If you do not have that mode feature, you have to create individually for when in min condition or max condition, hold, you have to make individual logic. But only you have to just assign at the state table, oh, whatever at this time you do min, max, whatever, you assigned it and it'll do exactly, that specified at the mod control. All inside, and rather than, like a minimum, maximum, whatever, we know, and everybody will know, just like, oh yeah, minimum, and we want to assign the minimum value, maximum, assign the maximum value. Control, yeah, control based on, flow, whatever temperature, whatever, I don't care, just like flow, it's flow set point versus flow. That's just, we know all. That's just, the PID logic stuff, but main core is not this. Main core is when you executing that condition. That is based on state table. This guy. Right there. When occupied mode, do this. When unoccupied mode, do this, and so on. So unoccupied is more high priority, because the unoccupied is, during the occupied wouldn't execute it because it's unoccupied, right? So unoccupied mode, they will just, if they need primary cooling, they do the control, because it's During the unoccupied mode, the journeys get heat up, and then they will do the control. The box is to start at the set point, supply box set point. Calculation will be start control to maintain the, blow down the more air to cool down. And then heating side, they are sequencing the warm-up sequencing. Warm-up sequencing is what? They have assigned the warm-up minimum airflow. So they have to do it that way. And then if you go up one more time, one more level, that's the warm-up sequencing. So warm-up sequencing is doing when? Is in the morning, right? When warm-up, cool-down sequencing. That is usually executed by what? To the head-end side, right? J's side, the supervisor side. Supervisory decide that like this one is a regular office time, is building occupancy time is 8 o'clock in the morning. Warm-up will be starting at like what? Whenever that that warm-up, cool-down, that logic is to start initiating it, warm-up, cool-down, whatever, based on that building temperature versus the outside temperature. They all calculated, and then they will send out the warm-up is right now we need a warm-up or a cool-down, whatever. They will start during the summer, cool-down. During the winter, usually warm-up. So, and then that feature, it will just execute it. And then when it's regular time go on, then warm-up is expired, and then go to the occupied mode. So when people walk in, fans start on, and then people start kind of uncomfortable until that's stabilizing it by the handle unit or boxes. They can prepare before people to coming in. That's the warm-up, cool-down feature. So building occupied 8 o'clock, usually is what? Before 1 hour, they're starting this feature. That you have to be assigned. That is a different feature from the supervisory side that you have to be assigned from there. Only you have to do the warm-up, cool-down contact. Actually schedule, command, write this guy from network input, the link from optimal runtime, optimal start-stop, actually, optimal OST start-stop sequencing from the main supervisory devices, and then they are sending out the command for the individual boxes, or even a handle unit. So stage, see here, now there's warm-up, cool-down here. And the next level is what? Output override. Make sure that is the output override. Output override LB. What is it? Where is connection? Sure. So output override. So this one is output override LB, which there is a time average. This is another feature. But anyway. Now, this one is, that's not just right, don't touch right now. Anyway, we're going to come back. And that's another G36. So we have like a predefined system mode determination and so on. So when system mode, this is good sample. So you select from here, system mode, hey, I want a cool only. When cool only command, then definitely you want a box or any heating side, you want to go, put on the off, right? You don't want to do anything, so put on the off. And then damper, just do whatever you're supposed to be. Astronaut meaning is do whatever you're supposed to. And then go to follow down. And then supply flow, set point, also do whatever that the downside, in occupied or unoccupied, whatever. And heat only, and also do the heating, do whatever you're supposed to do, meaning is you can pass by. So astronaut meaning is gate open, you can go down next level. Whatever you put in here, off or any mode, meaning is you stop here, you do this, that's it. They're not go down. Anything that you put the mode in there, they're not going down anymore. Down, lower priority. They stay right there. And so that's why that this priority is main decision maker right there on the left column. This guy is a main decision game changer. If they say, okay, I want to stay the box flow test, then they have to go to box flow test no matter what. And all others, during the box flow test, I don't care about the heating side, valve control. You can go down next. So I'm not saying that it's hard. It's like unfriendly. Oh, I'm not unfriendly. It's not used to. You may not used to. But if you start playing around, simulation, and spending maybe half an hour to hour for just this one, just look at it and how they're doing, and then you will understand it. Oh, yeah, this is, now I understand, like, see that the color change here is, green, and then do whatever, see it. Then just, you will see differences. Let's just do it. And I'm gonna just save, yes. And, oh, this is when you tested it, you can define the speed cycle time. So this is a 5 times faster than the normal execution time. And also, if you are kind of a hurry, you want to go more faster responses, you can raise up to the 10 times faster. So it'll just go down to faster, simulation. But usually 5 times enough. And then discharge temperature 69, I put the DAP, let's just say 0. And whatever, it's just like put down zone CO2, 229. I just put down already there. And then occupied it, and occupied override not set. Remote zone set point is a network only. You can change it, whatever you want it. And then start simulate it, and just to wait to see how they respond from this state table. So do a lot of simulation. Do not try to do by once. You focus on one. Okay, I want to do the cooling. I want to see happen when the zone temperature is way high. Then you just simulate it. When you simulate it, answer a question right there, condition answer. Put the zone temp to say 79, 80. See what happened. See right there is now green. So all the green, right? Left side first green. Water flow false, so do nothing. Just pass down, go down. PID false is going down. Uncalibrated, going down. Normal, going down. And see, you just see it. Now here, supplemental heating is not available. I answer say, oh, I don't need a supplemental heating. Then they will block up. Hey, you don't need control anymore. Supplemental heating logic, you're off. And why? Because I answer that way, right here. I answer, oops, what is it? What is it? Supplemental heating bypass, this one is actually from supplemental heating enable, here. But now if I say command to true, send it, state table. Now supplemental heating available. Okay. See now true is, I said, okay, now I have a supplemental heating. I have a fan tube, radiator, whatever, valve. It was off because I said, no, we don't need it, but now it's on, so it'll go down, do whatever it's supposed to do. So you just go down until you see that the green spot right there. See, primary cooling. Because I raised up the zone temp to over 74, so now we are in cooling, require cooling. So heating is off. Hey, during the cooling, all the heating is going off. And then supplemental damper side, you are doing control. And also set point, also you are doing control. Because only you can do the cooling is based on the controlling damper. So to control the damper is what? You have to terminate the right supply airflow set point. So right there, this one is actually guides you right here, supply airflow edge right there. This is it. See, control right there. Green. That is the link to that now in the control, and now input cooling set point is whatever that, oh, I cannot even see it, 1,000, whatever. And then process variable is this, this value, whatever. And then that's why the output is now what? As cooling output is 75.0. And why? Because there's a cooling max is 12,000 when it's 100, is a span cycle. So they are doing this way. So all these ones, everybody, you will understand it easily because this is just logic. But the determination of the mode is actually, that's the main key. That is done by the state table. You understand this one, then you are now, I can tell you are master of the CCT. All this, the other one is only take a time to just get used with it. What? Just to use with this palette. All this logic and all, block and whatever, it is all in the palette. I actually spending 1 week class to just to teaching only palette. Because that many. Activity input. Let's just bring up. And then activity output, Boolean, all these calculations, comparing all these features. Is anyone ever try one by one and then simulate it? Actually, I met this kind of class. I met about 7 people. Yeah, 7 people raise hand. He says, "Yeah, I tried every single palette. Every single palette." They said they put in there and they just simulate it, see what is it. And then they said, without any training, anything, they just try the palette. They actually understood the CCT. I was shocked. It's like, oh my God. And state table, they said, once they understanding that the palette, they said everything was easily, they come, adapting them to start modifying, troubleshoot, and then even they create their own logic. So that's, there's the people. There's people, they do. They're not doing like on one day. They say like just they do like a one edit, maybe 4 or 5 module per day, whatever they time left allow. They started to testing around and they had fun. And yeah, those people, so, they just think about it. Now these days, like everybody kind of crying for that manpower. Yeah, we have enough manpower, but manpower meaning is what? Knowledge people. So go for it, man. Just like, I'm not saying that you understand only CCT. Maybe you're dealing with the Honeywell or Siemens. You have to know all those software. Not only software, but you have to knowledgeable for their product. That's your future. After 5 years, who knows? Everybody will be. You can see differences. Who spend the time or not? Not only just spending time, just challenging. Do challenge it. I love challenges. I love to break down. I do break down once, really bad. It's a Kankakee courthouse. It was 1987. We had a DSC 8500. It's an old controller. And its program is you have to coding it. It is Cal 1 program. It is mixed up with Fortran, COBOL, you name it. It's all basic, and I programmed it to kind of opening vein for the chiller. Holy cow! Guess what? I programmed it backward, And I supposed to close down, so I open up, whoo, and then I can hear like, just turbine is going down. I was like, oh God. I just run around and just find the breaker and just shut down the breaker. I almost broke that brand new chiller. And downstairs there was a court was open for homicide in a trial, whatever. People was like, yeah, I did. So I always give it to my tech guys. Don't worry, do something. Yeah. We actually see some happening, but without the trying, yes. But now I'm just changing my kind of a knowledge after the CCT came out. I start teaching my tech that is like simulate it. I try it. At that time we didn't have a simulation, so we had try put the power on the CG, FAC at that time, but the CGM same. Power on, stick into the register, bunch of register in a dial register, potential, PT, and then put the like output for the light bulb or a meter. I gave them a bunch of analog 0 to 10 volt meter output the gauges, plus that voltage generator and the milliamp generator, whatever. I gave them a bunch of them. Then there's it. Hook it up, tested it. All the binary output, hook it up the light bulb. Just make sure that it's working before that throw into the real control out at the field. And they done. We made up the one wall in branches, in the Chicago branches, we one wall, all demo panel. And they start using that, and our trouble call is just shrink down 80%. 1 year, first year, when we have to try it, it was shrink down that much. Because we not throw in and test it at the outside. We testing at the inside, in-house first, and then we downloading the outside. But simply you can do that. I mean, now these days you go Amazon, looking for all the parts. It's maybe less than overall, maybe less than $100. You can just charge back to the company. Ask them, you want to just pay with this one to saving $10,000? They'll pay for it. Just need a potentiometer, and you need like a LED light, whatever, the small light for the 24 volt light, plus that the analog gauges. Hopefully this is still not, I don't know. All mine tester is made in China, so bad thing is it's not going long. And yeah, so this is the main core, and then whatever this is, the changing column, meaning is that they are changing value. So right there, right now, cooling percent command, the last value is a 17.7, and all those values, they are related from that each logic, but all this one is actually done by these guys right here. So you have to understand this first, and then once you're understanding it, now in all this up, and now you're only concerning two, which there is a supply damper control and supply flow set point control. That's only two you have to concerning it. So customer said, zone temperature is hot, but I don't get enough supply flow. I mean, they're starving to die. And then you go in there, and right here, first of all, I'll go check that collected supply flow set point and then connection. And then looking at what's the set point is, what's the cooling out. And then this one is going out to time average ventilation for G36, whatever. And why not they changing them much? But the damper is already 100% open. Because this damper position is now like, I don't have it, but right now 0%. And then DP, velocity pressure, integrate the velocity pressure is what? 0 inches. So something wrong. So those kind of troubleshoot. You cannot just troubleshoot like, what's going on? You see this logic and no, never do that. Always start with a state table. Where they are, you have to look at it. primary cooling. Everything is up. This is 5 control module. That's all you have. Go sending out the real actual output. Now you only have 2 modules that are related with the actual control. So now you can narrow down to, and now damper control is based on what? Supply flow set point, right? So you look at this guy first, and next this guy. So you look at the supply flow set point, and you're looking at it. Oh yeah, they are sending out some, good. And then go click the supply damper, check it, and you see the damper output is already 100%. Then meaning is like, oh well, damper output is already 100%. And then the DAVP is 0. Guess what? You have to go open up. You have to see that damper. I mean VAV box controller. Usually I see that Brody Precision is now selling the mounted boxes. That's good. But used to be, I mean, our branch here, how they do is we are not supplying most time boxes. And mechanical contractor, they buying boxes separately. And then we are only mounting our controller. But we are not mounting. We provide a controller, a CVM, to general contractor, and then they just using their people to put it in. And then sometimes they put it in wrong. Damper is like it's not stocking some, like they screw out. I saw that one a lot. They screwed it, and that the damper actually, that inside that the blade is actually the screws came out too long, and then they blocked that damper blade. And then the other one is they screwed it, the controller, and somehow guys maybe a first time do it or whatever, and then they drill too hard and then it just open the spin. After for a while, the whole now controller start spinning itself. Those things. It's not your problem. You can charge back your hour when you see that one, when you not installed it. But if you I see that back warehouse that is the person is selling controller, boxes, nicely secure, mounted it. So that's really perfect. But you will see it. Sometimes we are only providing controller, they are providing boxes, and somebody else is put it in that one. And then you may have to pay attention, because you cannot see every individual. Just to stroke the whole damper 100%, reading the CFM from the supervised devices, Jace, whatever, Niagara, whatever, just looking at it, and then just to stroke the 0%, look at it. That's the before commission. Make sure that they are getting the flow right. If not right, then you spot it, that all that box list, and then give them a general contractor that is like, hey, you got to check it that all the installation. It's not your fault. You're not installed it. If you do yourself, they'll appreciate it, but they don't care much about it. So next one is one thing that another one is a time average ventilation for G36. This one is just, they put, see here, TAV, WM, and TAV enabled it, random value. I already explained that too also in my PowerPoint. This is pain was. Now, time average side. Next page is, I just put on like a TAVV means what? Lowest possible airflow set point allowed by control. That's all design value. So you don't have to worry about it, but they have to give it to you. If they want to apply G36 in mechanical contract that the room
schedule, they have to provide all these values. Then you have to just only do is like, put it in, that's all. You don't have to change anything because default is all 0. And sometimes, like if they're not even required, then you can put the TAV enabled to false. But in spec, when they start seeing the G36, then it's got to be true. So that's why the CAN program, when you answer it, if you see that the G36 or HVAC 62.1, then you just select the column and it'll dispute this out. But if you don't see in the spec, then you don't have to select. Then you'll go to standard, VAV boxes logic, which without all this, G36. Well, this makes sense. Another one is, another way that the flow set point is like, when it changing it. But I just put the, also this one is I copy out from that another brochure to easily understand it. So, yeah. And zone heating control state, here. The state table, I just kind of put here what is state table is, and then I just put down, priority high and low, priority order. This is state generation, connecting from state generation. This is output control, 2 output control module. So just some explanations. And usually when I give you kind of a slide and show it, explain to you, easily understanding it. But when you do it, it might be slightly different. So this time I already kind of, we spend almost 3 hours to just review just review it. So this is the time. Let's launch the CCT and start to create your own VAV CAD file. Just a question and answer. Just try. And then I'll give you like 5 minutes. No, I'll give you enough time. So just let's do it. So we'll see. And okay, I'll bring out my selection table. And you can change it whatever you want it. Leave it that they integrate the feedback because you can just disable the feedback if you're not monitoring the feedback. But you can try. But like box heating, you can change the proportional output if you wanted it. Or you can just say the supplemental heating is you don't need it and just deselect it. But try yourself, see what happens. And when you're done it, then we're going to go next phase. We're going to go start doing the simulating your program. Just see. Meanwhile, I'll go get the coffee because when I was there, it's all out. summer winter compensation set point shift. Sometimes they do. So whatever that we put in here, all option, is we put as many as possible that we can cover that specification, sequence of operation from that A&E, mechanical contractors, mechanical design. I mean, these guys sometimes like they are requiring it, sometimes they don't, so it's an option. That's why we have so many options right there.
That summer, winter compensation set point shift,
Yeah.
how does that work? I thought it would work like, you know, people like it 72 in the winter and 70 in the summer. I thought that's how it would work, but it doesn't seem to work that way.
No, shift meaning is just temperature and plus minus upset. They are shifting up, not summer and winter. So now you see that, okay, so it doesn't work. And because of that, maybe that the shift is maybe, I don't know, I didn't try it.
Okay.
But if you don't think that is not work right way what you think, you can just create your own zone reset, set point determination. That's easy. I mean, we put as, you look at it like our CAD file that is like cooling unoccupied, heating unoccupied, standby, occupied. There's 6 differences. And the shift, actual shift is working at is you don't need all that. You just put the shift and then the set point from the dial, whatever, 72 or network 72, then shift will be decided. When it's summer, then just raising up, winter, raising down. So kind of compensate that set point. But you can create your own, zone set point determination logic. It's easier, a lot easier. I mean, please, I'm telling you that is like, I keep telling you that is like a CCT is not for the one type of, specific equipment. It is for the multiple purpose. So it has unnecessary points, so many unnecessary points that you don't like it, then you can create all your own. Especially zone temp determination, easy. You can just, you can do by yourself. How? So I think that most people done. Good. So zone temp, I just say name abbreviation. Zone temp set point determination. And usually I put my initial when I do my own. Please do the same your way too. I mean, please do the same way because you want to separate out from that original, CAM program versus that your own custom program. Some people, they want to put their initial at the front side. That's good too. So anyway, just make sure there is a difference. So, so now say, same thing. That is, if you have like a hardware, specs that require hardware set point, that's fine. Then hardware input AI, that is like hardware Jones temp set point, right? You link that from the input and go there, and then block it out. That is like a plus, adding, and then differences, offset, whatever, bias, I don't care what name is, bias or DIFF or differences or offset. There's, people kept using it, but we are standard is DIFF, but who cares? And put down that into, this one is a cooling set point, and then subtract and set point. And then this guy come down here. This is a heating set point. This is occupied points, right? Now, during the unoccupied, you have the different way. So this is whatever then. Now occupancy. Occupancy mode usually come out what? EFF dash OCC, whatever. So when this one is, like you put the MUX, float IO to the enumeration. So you put the EFF, so OCC, unoccupied, and then bypass, and what is it, the standby. And so you put this one into link to here, and then occupied, you put the you have to make a two. So this one is for the cooling side, and the other one is the same thing, is heating side. Same thing, so you just put the link to this one to here, and during the unoccupied, the same condition, you make a maybe unoccupied, you can specify that the unoccupied cooling set point. You can do that, or you want to just using the offset for during the unoccupied, I want a 10-degree differences, then put the unoccupied differences to 10 degree, and then a plus and minus the same function. And for the different calculations, so this is what we call it the OCC, whatever, OCC, and then same model that you can put it in for the unoccupied, and then you can link it to the unoccupied and bypass, standby, same way. That's the your own custom program. I did this way, but you can do different way. It doesn't matter. I never say that we are the CAD file, this standard CAN program is 100% perfect. No, I say 80%. 20% we need your input. We need your idea. That's it. It's like I always tell people that CAN program is help you to start up, but it's not finished. You have to finish it. You have to be completed it. Completed meaning is testing, validated. That's the complete. CAN program, throw in, oh, I'm done. No, it's not. Then you will see nothing but just headaches. So any logic that you see now, your program, now you see program, whatever you see it, any primitive, the white block that, just leave alone, but anything that the logic, you can change yourself. I'm encouraging you to changing every logic, every possible that allowed to changing logic, change it. Try change it, at least one. And you will see big differences. Meaning is you will see that how these logics are working. You can actually confirm understanding of logic. Please change it. I don't care. Anything. Zone law limit determination. Right here, this is a simple one. See here, zone temp. This is the most easiest one, right? If zone temp is less than zone low limit set point is right now 41, and then whenever they lower down to 41, zone low limit state is go to the right now is enable. What is the state? Low limit. And then whenever that once that this is a latching, everybody knows there's a less than, and then put the difference is what is the latching logic. You don't like that? You can create your own, and you can using the latching logic. And to understanding that this less than is this. You go to timer, you create the latch, and then compare less than. And zone temp is the less than set point, and you are latching. Once the latching, you have to reset sometime, right? How? You have to add, because this is cold environmental, so go where's the math? Math, add. And then you adding zone set point plus the differences. So now, if this is greater than or equal, it doesn't matter, but the greater than. So zone temp is now greater than zone low limit set point is 41. Difference is say 4 degree whatever. So once that lower down, it latching it. It'll stay there. That is it is low limit control. But now zone temp is rise up. You don't want to disable that feature as soon as that above that the 41. You have to give them some differences, some offset to give them a time. So what I done is I adding set point plus that the differential, and then I just link it. So when this is happen, when now zone temp is now greater than 41, so 4 degrees, so 45. If greater than 45, you can reset this guy, and then I'll just simulate, just testing out, but just copy out this guy. Now you can do same this one. Sorry. I should have done this way. I say this one. I just copying out. Right here. So now I interpret this less than and then with the differences, the logic, I actually translate at the bottom. This, so using one object to, why are we using this one? We put the difference feature because we don't want to using 1, 2, 3, 4 more object plus 5, 6, 7, 8, 9, 10, 11. That's a total 11 object. And then this one is only required 3, 4, 5 objects. So we are saving 6 objects spaces, memory size. That's why we are using this kind of feature. But this is more easy understanding, right? A lot easier. You will see it. Oh yeah, this one. Oh, I want to, instead of greater than, I want to use greater than equal. So as soon as it above 41 plus 4, so it's 45, then I want to reset it. Yeah, you can do that too. So this is just sample. You don't have to do this, but I can tell the people that is, don't hesitate. Just if you think that you can change it, try your way because you have better knowledge than MIT people at the field. Those guys, maybe theoretically they are smart, but at the field hand side, they're not even went down to any flow to see that what VAD box is. So you have to be make something that easy for you, easy for your operation, saving time. That's the main things, and then also easy maintained logic. So in future troubleshoot side, make it easily understand it. I give you this morning for 3 hours for all this that is for the based on the standard logic. But you have to be kind of memorize it. You have to get really used to with it. But if you create your own way, then it may be a lot faster to adopt by everybody in your operation because you guys see the same things. But G36 inch, G36, HVAC 62.1, those features don't change it. Just use it. Don't even bother. So anyway, this is the same feature. I'll just save it, but I'm gonna save rename it, and then I'm gonna put on the back sample and test. So we got 2 of them. Same thing, but it's 2 of them. And system mode determinations. Okay, so whenever system mode determination, system mode is what? Is coming from that network input and cool in all this. So water flush right here. So whenever they equal to water flush, I put this, these descriptions. So you open up that your logic you created it for the system mode determination state generation column, and you want to see this nice, text. You can put it in. Please put as much as possible for text block that it'll just say what? It'll just say like a enumeration, check whatever. But if you put more explanation text mode, and it'll help for the troubleshoot in future. If you have a more, I say if you need more explanations, I usually try, I put this somewhere, but, where did I put it in? Hold on. Anyway, let's say here. You can use this one, text, right here, on the palette, on the left top, second one. The text is actually text block that you can put it in. So I can put this text right here, drop it in, and then double click it, and okay, for training purpose. And then you can put whatever you wanted here. And system mode selection is for water balancing, whatever, it doesn't matter. And then you apply it and close it. See right here? Right here? You drop it in there. And then it's not doing anything, but it has descriptions, explanations. So in future, oh yeah, you open up and you just write on. Right now, the only memory is only what, 33%, so you can put a lot of stuff in there. I actually give them this kind of an idea, and then one guy, he created a single loop, there is a side loop, he created it, and he put a nice description, actually simple sequence of operation, the text block. So whenever they open up, whoever, even after 5 years, another new tech coming in and then look at it, he'll get right into a spot that he explained. AI input coming in, whenever, whatever, the degree up, and then you do this. He put them very nicely, and he put a spot in there, and then, just like when you open up, whenever, whoever open up, that'll be easily follow. That's another, tips. And some other people, they are really some special boxes. What they done is they actually create just active logic, and then they put down the note, and then we can put here's the project information. But what he done is he put the text block here. And he put down his contact name and so on, and the date code, and then what he done. And every time who changed it, they just keep adding it. So this is more likely historical trend that for the modification of the CAD file. I see a lot of I just give them show them the power of the future of the palette. But people using very smartly. I was really impressed. So every time they have the guy who done it is like a balance report. He put down all the value, gain, and those things. And date, first he put the date, his name, and then he provides this is provided by the balancer, and then he put down area, gain, and all those things, like a cooling max, cooling min, nicely. So in central station, somebody screw up that set point within changing it externally. he can pull it up that the CAD file and he can look at right there and record. And then they can just, readjust it. So I was really impressed. It was not my idea. I just only showed them what the feature of the palette, but people just kind of generate, adapting it and then using more tool for them. Yeah, I was impressed. But pay attention. Do not ever exceed 85%. Then you will see the slower responses. But 33% to the reaching up to 85%, you can put 100 of those things. It's fine. Just count it as like one is one block, one object. So that's it. So yeah, that's another tip that I missed the last time in California teams. Occupancy mode determination. This is most people said sometimes they don't even have arc sensors. Most time they don't even have a temporary arc sensors. And sometimes they don't even have occupancy override feature. They said, why there is so many things? Yeah, create your own. Please. Oh, I have another tip. Go double click it. And then anything that you're not sure, right here in the corner, question mark, helpline, click it, and it'll open up. John's Control, CCT helpline. You open up, and then they'll say occupancy mode determination, what is it, so on, so on, so on, so on. It'll explain to you all. And then you can go primary state, boom. And then primary state, this is how they determine with all related possible metric and result. I create one for follow this one, but why do I use it? I throw away. And usually I depend on for the project. This is all based on the project. One project may require temporary occupancy. One project may require occupancy sensor, but most time, big campus, they don't even have this. But if you go to the campus, school, they have arc sensor. So when classroom, even during the normal operation hour, classroom can be empty. Then you're using it. But the commercial building, they don't even have an arc sensor because it's, they know exactly business hours. So. But if you want to using arc sensor in future, I think that the occupancy level, occupancy population, that may be more feasible. That may be more, I say, they already applied it in a G36, isn't it? So, but if you don't have inspect or designing, drawing, you don't see the temporary occupancy sensor, then rid of this one too, create your own. Simple. Occupancy override priority one, isn't it? No matter what occupancy schedule is, if occupancy override is occupied, it's got to be override. It's got to be occupied. Then you can just create a hierarchy state and just, two input with the several possibility of the comparison metric and then done with it. Most times, each project, they are all same. They're not mixed. Maybe one box has a sensor, one box doesn't. No, usually there's one set because that's how they designed by the mechanical engineering company. But see what happened. Arc sensor, I see a lot mostly in a school future. But the commercial building, I don't see much at all because they don't want to spending any hardware input points in especially lease building. No. But in future, they may be more interesting about that occupancy level. That's good. That's really good. Anyway, that's the things. And effective occupancy has like occupied, unoccupied, standby, bypass. The bypass is third, and then standby is the last one. So that's the 4 option. Everybody keep asking, like, hey, why the not set is there? So not set is another feature. The not set, you can put the not set. Usually default right now when you put the not set is bypassing and override. And then occupancy schedule, when you set the not set, is automatically go to the occupied. But you can change that if you wanted it. But also you can, I told you, if you create your own, you can rid of that not set feature. Because not set, we put it because it's default. So whenever that we generate the first time, and just like not set is just default, so people don't have to be just to do something. Just not set is a default go to occupied, but you can go default for the unoccupied too. So anyway, this is a helpline, very handy, and only they missed it is like once you select one, and the next one, say, yeah, this one, and then I go, oops, hitting discharge reset and so on, and if I go PID, I click again, answer it, and then it's they're popping up to another page, another tab. So. Sorry, we don't have that much future to disabling previous pages, but so this is it. So the PID is right there, and then you can just see that all the explanations and about the PID. But don't wasting too much time, because I'm gonna also provide you that this handy reference sheets for the Metasys System PID Prac help guide. This is my Bible. Every time I go there, I told my tech that is like, put into your computer. First day they joined the Johnson, I give them several reference, guideline. That is, one of them is this one. Person that who got out and joined our HVAC world, they don't even know what is a PID. It's okay. And I tell them, don't frustrate it. Just put into auto. Everything is just default, which is default means auto auto cal. Auto prac. And then I tell them to go down. All this one is like all the theories here. You can just read it and then you understand it. This is very, very helpful guide. They're not coming out anymore. So these are all detail. And at the bottom here, this is, I call the cheat table. If you're doing the chill water, and temporarily you can put all this initial value. Don't put the Celsius. I see guys who put the Celsius. He didn't pay attention much. Maybe he just put the first one, 20. Oh, damn, it doesn't work. Why? Because anyway, this is a cheat reference data. So you can just go look at it, and then you can, this one you can use for the one single, like a side loop. So, but because when you're asking Q&A, they already know, so they put all this, default value. But in the side loop, you can just put this value. When it's a chill water or pump or pressure, usually pump is a pressure, right? And then duct, the fan is a duct static pressure. They're all here. And then using that the 6.x, that is that's a 6.x is that's the CCT version. This brochure is a stop at the 6. But right now, so we are now what, 16. Oh my God. But they're all same, meaning is they're all same. Sorry, it's a CCT version, and then this one is different. When you see that the logic in CCT, there is a call at end is a V, is a version, right? Here. See here? V51. that is follow that table, yeah, 5.1. So now you raise up the more, newer one, you can change that value to 6, which it is, any differences? No. But some of them is differences. Because that's why we're still using in the auto, CAN program, they generate, version 5.1, and some of them is a 6.0, whatever. That is kind of it all depend on. And yeah, pump. Where is the pump? Yeah, pump. This pump is right here. Pump DP. I thought this one is, yeah, difference here. Pump speed 5.1 is we are using before we all used the one which that is what? Interval, period time. And then we found out that the pit loop was like a swing. Because sampling time 1 second is like too much, so it was a swing too much, so we changed it to 3 at the 6.60 actually. So those things. So you see it, and then you create a single loop, one of your own loop, just apply the highest 6.x data, then you're safe. And then pit loop tuning, manual tuning. Sometimes you have to do manual tuning. Some customer actually put in the spec that all the PID loop has to be locked. When after they said, when commissioning done, when validated, you have to lock the auto tuning. What is that meaning? They don't want to do any more auto tuning because the error, delta error, kept adding up. Just like we are in the morning, we explained about it. That the delta error get rising higher and higher. Then when they reset it, is a kind of a fan or a pump can swing high. So what they meaning is, you go there, say box heating control. The pit loop. Here is of course that pre-pit. They said lock it, meaning is instead of standard tuning, you have to select the false. When after all done, and then before you false, you have to copy from effective process range all the effective value to the process ranges. The process range effective, you have to put this value to there. Because right now this is brand new initial. This is create the new one, so it doesn't have anything. But once you run it auto tuning for like say 4 or 5 hours or a day or 2 days, the data value will be all differences. And then copy that into each individual parameter. They copy it in, and after copied in, you just go to standard tuning to false and save it. And now, no matter what the delta T is, that change, that whatever that you gain from that period time of this auto tuning value, that will reside in the pre-pit. That value will be always sending up, no matter what. And then, once you're done, and on the PID, go to PID. Why? Go to PID. You don't have to do manual tuning, but adopt tuning, you can set to false. Adopt tuning meaning is that they are automatically calculating it. So we don't do any more adopt tuning. You can lock it. And then then that pit loop. Any cases, some that outside disturbances, it didn't care. It's not going to calculate all the delta error. It'll just continuously sending out the same parameter that we locked it. Some customer, because most ex-Johnson customer, they prefer. Why? because they don't want to see that happen. After power outage, after accidentally somebody shut up, fan motor instead of disabling from the station, you just walk out. You know the most maintenance guy just boom, they just changing filter, turn it on, walk away. They don't care one fan swing or not. And I say, oh, after 10 minutes they'll be fine. They walk away. But yeah, all the people in the building, they not feel good because it's when they hear that the diffusers kind of blow out the air sounds and up and down. They don't like it. So some people calling for trouble, just like complaining. Those things, that's why once they lock it, they don't care. They're just sending out the same value. It's good. Well, if you tune nicely for giving them enough time to get the value. If not, then it's not. Think about it, it's like a balancing, everything is perfectly done, is good, but if not, then fan automatically, after the times go by, it'll be different, characteristic is going to be come out. So, but it's up to customers. So, you can once they print the spec, you cannot change it. So you follow it. But if you don't see that, just just leave it alone, let it run, and then just put the schedule PID tube new tuning once maybe once a month or once 2 weeks, whatever. Just do it, and then yep, that's another tip. Yeah, this is very nice. I usually had a printout that I always carry around in my bag because sometimes you don't want to turn on the paper because the computer, and I usually just looking at from that usually display because I define sometimes the pump control, like a critical pump control. I usually expose this parameter to the backnet display. Display at the a CCT here. Another feature, display. Edit. Right now, all default is empty, right? And you can create it a display, so you can use our new display. And even though, do you use a new display? Tom, are you guys using any display for our controller?
Like
The new one.
the one that would plug in.
Yeah,
old
yeah.
XDIS 17.
Yeah, but not now. Newer one is what? Yeah, newer one. But
So everybody in here got the display version of the CGM, but then if you get it without the display, you use the remote mount one.
okay, yeah,
They were selling a fair amount of those.
good. Yeah,
Stuff like that.
yeah. Sometimes when you have display, then you can create your own. But if you create the auto, hit the auto, it'll dump everything that the backnet exposed point. And then this is input point, input output, and parameter, all the parameter. And then once you selected it, and then also that the idle pages, idle page meaning is whenever display turn it on, it'll automatically idling it by itself. And then you can define that like, oh, I want to see that VAT into idle, or to drop it in. Oh, sorry. Yeah, right there. And you can just drag and drop for the idle pages, only critical one. And then you save it, and then you plug into display into that your CGM or VMA, plug it in, and you will see that value. But a critical value for the, just like I mentioned, the pump, the manual tuning one, I usually expose that PID tuning value into the separate one into right here. So you see, I just put down the say pump PID data, whatever, and then I put down here all for the parameter into that folder, and then I of course this one I don't want anybody to see it, so I also put down the security level here, the password and ID password. Make sure nobody can change it. This is another tool. And I don't know if there is ever used it, but this is handy. And then anybody using the advanced tab here? Because you can actually put the schedule. This schedule is different than the supervisory level. This is a local schedule. So you can put the schedule, your own schedule there. Like in a single loop, I told you, like in a side loop one, and sometimes you need to enable only certain time and date, and you can create a schedule here instead of from that supervised devices. Especially this is usually happen when it's job's almost done, and then suddenly customer asking, hey, can you put that pump control into your VMA, because that's the location right there. You have a spare point, and then fine. Then, if they want to put a schedule, you can throw the schedule in there. If they would insist to put the schedule into their front end, they can do that too. But option. And yeah, and calendar. You can put the calendar trend. I use the trend a lot. Not a lot, but just like one critical one, like a pump control. When the commissioning phase, when is the initial startup phases, I put the trend and just record it, because usually when project start up within that one, not boxes, but to say maybe a pump control, it just start up right, and then there's no supervised device connected yet, then you can just use our trend, a local trend. This is a local trend. And then your controller can trending data. It's not a lot, but at least you see the couple hours trend, and then you can determine that your pit loop is right or not, working right or not. So please be aware. Anybody using the parameter sheets a lot? This is good. Also, when you don't have that supervisory device, when you don't have able to access the JACE or whatever, Metasys side, then you can just individually VA box troubleshoot. Instead of looking at the logic and light changing color, you can just look at it here. This is all backnet exposed points. You can monitor it from this table. And what's the current effective occupancy? They will just changing it. And value, CFM, whatever that you expose to the backnet, they're all displayed here. That's why I prefer to using sometimes see here the simple table. Simple simple table view, like this column is input, this one is all the parameter, and this is the output. Instead of open up that classic view, I like to see that even simple view. And you can also create your own view table. That is under setting, prospect management, and you can create your own. Right now, simple view is input in application folder is input, parameter, and output. But you can create your own, your name on it, and then you can just create your own, whatever you wanted. This is, I encourage it to every branch that create their own simple view for boxes, air handler unit, or whatever pump control separately. So when they do the commissioning, that system, instead of watching from the CCT changing, all this value, your head is going crazy. You need something that only a state table, that's fine. But if you need more than state table, this simple view is better. So customize your view. And you still have a, I mean, hold on here. So, where is my, oh, here. Anyways, all the parameters, you can, same thing is a click the parameter and then it'll tell you. And then a simple view. And here's, it'll tell you how to even create even custom, okay, here. See, go to perspective management. You just type it in and it'll tell you how to do, create and adjusting and so on. So you don't need another, booklet or whatever. It's all, as long as the internet's available, it'll guide you to the helpline. And only you need in your computer is also, that I'm going to share with you, there is a CCT control tool help, but is also this one you can get from help and topic PDF. Click it and then just save it into your computer, and then CCT PDF file. But you know how many pages this one? This is. I was. Oh, where is it? Oh, I didn't open up, didn't I? It is quite a bit. It's 1,700 something.
1,600.
Yeah, 1,656. Anybody has to read all from first page to last? Hey, I saw some guys. They read all. Yeah, I don't know, man. I read maybe 2 pages. I was like, really, this is like, oh, but now these days, like, PDF has nice features, so you can go find your, whatever you want to see it, go, alternate F, and then just searching it. But yeah, it's tough to look at it. So yeah, just reading all, maybe a project is ending. So anyway, yeah. So now is the future. There's a question mark, any question mark there. You can click it, and then you can see that references line. And right now is what, 11:57. We're taking a lunch.
Lunch is here, everybody, so lunch is right outside this door. You can sit out there in the kitchen, come back in here, some fresh air, come outside. One other thing, I'm doing dinner tonight for anyone who wants to join us. I'm going to ask again right before you guys start back up to do the check with wife and kids and whatnot. I got to get a head count so I can get a reservation so there's dinner. Afterwards, let me know if you want that.
Wow, you provide even dinner? This is the first time. So gentleman just asking about it, connecting, if we created their own custom program, how to connect it to the state table. So now state table on the left column, priority one, there is like, when you connect it to that one, you have to create that the state table yourself to match that the enumeration set. Enumeration set has to be matched. If they're not matched, you cannot connect it. So when you create that your own full custom program, I usually recommend that gentleman said, oh yeah, he usually used that the generic program for like if air handler unit, select air handler unit. Maybe he can delete all the all the logic and he create your own. And then there's another way to do it, but the same way. I mean, if you mix up with CAN program logic to custom program logic, sometimes it is really can be a headache. So if you want to go to the fully customize it, just simple one, you can try. But I usually do not mixing together because it is more harder to troubleshoot in later on. So, yes.
Sorry, I have a kind of part of the question.
Sure.
Along that is that, so when we do create using the system select and everything, have everything, and then later on down the line, shit, I need to change to a warmful adjust or vice versa, whatever. You already had all your custom stuff in there, but then when you go change that one setting, it blows everything out.
If you select that, if you select the system again.
If you go back, using the same order as this, you want to go back to system select, change.
Yes, it's only going to be blow up.
Is there a way to, one, prevent that, or two, in order to get like a backup of it, to put it back in?
No. But there is another way. Yeah, it's good to. Yeah, so now it's like, okay, so let's say just go to the same. Yeah, just test AHU. And then we're going to create a mixed air single duct. Okay. And then, just leave alone with that, simple. And I don't care much about this. And just hit next. Finish it up. Now it'll just generate, is a select program will be, create that the mixed air single duct CAD file. Just, let's not worry about anything else. So now, gentleman asking is almost as, it kind of, mix up together, but, he asking about the state table selection. He asking about that, how to managing the CAD file that generate by the standard file. And after that, you adding the custom file, and then you deselect that system again, it'll wipe up whatever the custom program is, it blew up. To protect that one, said like, okay, discharge temperature set point. Let's say just you did something else. You change it here. Then I just said, I told you that's just like JCI, and then just put in the name. Determination, whatever. And I just, say this is you just, customize it. Then I usually export module. Export module and save this one as it is. And then whatever you put in a custom module, you save it, export it. And then you changing it and then re-import it and then replace with whatever that existing one. That's the only way. There is no way that, just kind of a combining and
Then you lose all your links too.
right, yeah. To avoid that, I usually using the straight, 100% custom, program. Yeah, because it's blew out everything. Because once you create your own logic, start build up your own logic, always export that module, save into it. You know that the folder that they're saving it is under C, program data, and then there's a Johnson control, CCT, Metasys 3, Metasys 3, CCT, and then there is a UI, and then there is a custom control module. There is it. That folder Actually, they're all, if you exported it, they'll save it here. And then this one is like you can managing yourself. And so when you don't use matches, you can split out, like you can put in some other folder for your own custom module, folder for handle unit, VAV, and whatever, and then you can just save that into that folder. But when you reuse it, you can grab that one and paste it into this folder. And then in CCT, once that module's in this, under this folder, you can import. You can import to whatever that to say JCI, I put the abbreviation right there, and you can reselect and you can bring it back in. Only the module that in that under that folder, custom control module. So you can manage that way. Otherwise, yeah, if you select the system again, boom, adios. there's no way that there's no way that you can recover, unless you have a backup, But and also the other question was like a state table, and then state table. They see here the connection, and they show all. Whatever that link from that the state generation, well, it doesn't matter. Even you can put in from the network input, whatever. That if that enumeration set has to be matched in the state table. That's the way that only they can connect it. When you Q&A select the system future, they're automatically generated. But if you make separate logic that has enumeration set, then you have to create the condition at the state generation, and then also you have to create in the state table, you have to create that the state table enumeration to match that logic so you can connect it. Otherwise, so this way, like I go here, say edit, and under this right here on any bar here, top right button, create a state selection table, meaning is on the left side column, and then create a state selection column is on the control module. So say we are now creating a state selection table with the left column, and then I'm not going to name anything. An enumeration set, I'm going to put down like up and see what I have here. Up on control. And then priority is 18, but I said, oh well, a priority is a 0, top priority. And it'll dump on the top. And I save it. Okay? And then now I create from here an activity. Activity meaning is like just blank sheet blank paper, just blank one. Hybrid activity meaning is like a condition program pages. So say it doesn't matter which one you're testing it, but they just say this is test state table selection. And then here is on the bottom, because you didn't link it. Whenever you create a new one, if not linked it, it'll drop into the bottom. And so now you go logic. I say whatever the condition is, logic, blah, blah, blah. You can put the input, output, or whatever, but the output, say that output that has to be linked to that state table. This output, that's the test. Oh, sorry. Rename it. Test state table, whatever, and go there. I have to make off, on, control, make it same as a state table, and then select that to the default element. Meaning is, if you don't select that the default element, which is it's not changing out the black, when you run it or simulate it, the value is not going to show on this state table the logic here. Once it's simulated, if I select the default element, and it'll show under this one at the value. Anyway, show all. Right here, the first one that we're matching and we're connecting it, right click, make a selection. Now you can select these guys, that what we just selected it. Look at the name, boom. Automatically it fill. Test the state table selection. Dot test state table, which that is. Now it was at the way bottom, but now we select the priority 0, so it went up to way high, top. So that's the way that how to link from condition built with the state generation logic to state table. So knowing this, you can just create very simple logic, which that very simple logic that is like say you have one single loop that require to create by spec that's like, oh no, as a customer inquiry, whatever. Since that your CGM has, your FX CGM has, some points available, and customer can ask, even though that is a main and the unit controller, they're controlling it, but they want to use it. Okay, they said one pressure for the say water source, and then there is a pump. VF, and they says pump set point, water pressure set point 10 psi, and they want to control the pump speed. To do that is like, okay, now to control pump speed by water pressure. Now, there is a condition, right? This is before the programming it. So now you have to be determined what kind of a scenario needed. First of all, up condition. When is going to be up? And then second, when is max speed required? Or 3, it's not a, it's not a standard. We are now making a fully custom program. Now say max. The next one is say hold. When you want to hold that pump, usually holding when? PID tuning, right? So we need that one. And then 4, say control. So we need a 4 state to control the pump. When up, there's conditions for, say, network enable, disable, command. So at the main station, operator can disable, enable pump control. Second, safety. Safety is for what? It is when pump command and status mismatch. I send the pump to command on, pump status doesn't come on within 30 seconds, and say, hey, I want to lock it. That's something wrong. Or sometimes like, oh no, I don't, I will give at least 3-time trial, strike out, future. Yeah, you can do that too. The max is same thing, is like whatever the condition, when max condition is what? From the, yes, a network command. And then hold, PID tuning. Control is just normal operation, so controlling water pressure. So this is, before you jump into the programming it, you have to make a sequence. This is a condition. Usually you don't create it. Usually just the specs coming out. Hey, I want this condition to control this way. But sometimes, like customer will be asking you to create one, then you have to do this way. And control pump speed pressure. So we are throwing into the air handler unit, and then priority. Does that matter? It doesn't matter because it's totally different loop of the air handler unit. So the priority can be located at any place, right? But usually in this case, I put in the way bottom, separate out from the air handler unit. So I will just create one, and then we're going to create another logic that we're going to create it, and we're going to create it together. So say, I'm just going to use the same things, but so what we needed is we need one enumeration and one enumeration, no, maybe two, but it doesn't matter, but say pump sequence enable, and then water pressure set point. Okay, now pump sequence enable. If you put the description, please put the description, because it's, when you expose to the head end, it'll just bring out. Otherwise, it'll be empty, and then somebody have to retype it in from the head end side. So, but I will skip it right now. But shutdown, enable, and the default is a shutdown, and then water pressure. Water pressure set point, say 10 psi. And output, it is for the pump output. So anything fine. Condensed water pump, 0 to 10 volt is the same, 0 to 10 volt. And then you can come out here changing name if you want it. If you don't like it, and then just go there. Water pump output, and then you can just delete it all out. Okay, so now it's a water pump. And then state table, say it is like, okay, now it's a state generation. We're going to create one, and let me just delete this one. Let me go there, delete that one. Okay. Good. So activity. So pump control sequencing. And let's put on the front side. Oops. Home. Go in there, view logic, and input. And I'm going to go to sequence enable or disable, whatever, and then shut down. And then input for water pressure. pressure set point. Please watch it because otherwise, because after as soon as it's done, and you're gonna do it, so you're gonna do some other things. So set point, and then output is enumerations, whatever. Okay. I want to put just a full one, so I'm going to put my own custom things. So pump, sequence state, and state 0, 2, 3, which there is a 4 of them, and backnet. Okay, so now you apply it, and backnet expose. If you're not exposing it, you can put your custom enumeration. So you have to put the backnet expose and save it, and then now there's a full state come out, and we're gonna say first one is off, next is max, next is hold, and next one is control. Of course, we do have that feature. I mean, state, already a standard state, but this is just I'm creating this sample, pure 100% custom. So you can create your own enumeration table. So you apply it, and then when system sequence enable, okay, and also we need another one, which that is interlock mismatch alarm. Mismatch alarm. And then mismatch alarm usually what? That the condition is normal, enumeration is normal alarm. And then just leave it. So now I'm going to be fit to that, and then select it all, align. So now compare it. Okay. So, oh, we don't need this one. Sorry. What am I doing? Not here. So what we can create is we can create that the state on the command hierarchy for the enumeration output, and then you go in there, changing this guy. We don't need the Boolean input, but we need enumeration input. And then go edit. Now first one, input 1 is shutdown and enable. Input 2, mismatch alarm is normal alarm. And then output, say we have a state 0 to 4, 0 to 3, which is a 4. So, okay. Now, when this is a shutdown, no matter what, I want to state 0, which there is a state 0 is what? Off, right? Hold on. Let me just go there, change this guy. No, we don't need that one. Sorry. Not there. So, you have to kind of, know which one state 0 in here, because this is internal command hierarchy. And then now when enable, this one has to be normal to run. And normal run to say 3, which say 3 is a control. Let's just leave it for a while, and then we can do the add-on. It'll be asking you more, but also, sorry, one more in the low. Anything, no matter whether enable, and if this is alarm, we want to shut off. This condition matching it. Now all condition matching it. Now you link it. Cancel. Did I change that? Shut down. Yeah, I know, but hold on. Let's see. Input tag. I thought shut down enable. It is right?
I thought it was off on for the sequence.
No, shut down. I did a shutdown enable. Hold on. Yeah, now somehow it's like mismatch alarm, normal alarm. And now these guys go to down there. And then I'm going to select the default element is a pump state, sequence state. Now this is done. Now we're going to select this guy, input 1, sequence from that network input. Now alarm is not there, so how you create alarm? So interlock, equipment interlock. So there is a equipment interlock. And I'm going to call pump interlock. Usually they, I don't know why the Johnson you like to using interlock, but just now you have to have a pump status. So we adding pump status and condensing water pump. We're using a dry contact, and I'm just using that, water pump, whatever status, and then the water pump is the make a same with the water pump, and then water pump control output, pump command, and so now water condensing pump, and 24 volt maintain, because that's the dry, we have to use that one, please. WTRP, okay, right there. And then in the control logic, you have to create that now hybrid activity, because that control output has to be control, pump control. Anyway, whatever. Yeah, this name is okay. Well, so what? Okay, so now this one is, we're going to change that to state 0 to 3. And then input enumeration, same thing, and we're going to put the 0 to state 0 to 3. That is a mod which is coming from state table, and now they are matching, so you can connect it. And now you can select it and then align to center, whatever. And then now you can send out that, based on this condition, you can control the pump command plus pump speed output. So we need one enumeration output, and one is float output. So this is a pump command, and this is a pump output. And then in control, we need water pressure, and we need water pressure set point. So I just control and copy, Control C, Control V, try the saving time, and go end and set point. And then state 3, we know in state 3, so now, since this is not magnet exposed, that's why state 0, 1, 2, 3. But if you want to see it, then you can just view, go detail, and then say true. And then I'm going to say pump out state. And then apply it, and then changing name, changing enumeration, off, max, hold, control. Oops. And once I do that, now right here, nicely, they done it, so that's fine. So now you've done it. So when it's up, meaning is what? You want to up. It's up is up, right? So up is constant. When it's up, you want to pump to off. And default is off, so just go off. And then when it's up, pump speed, got to be 0. So default, whenever you bring it out from the palette, the default is off on enumeration. Default for the float is 0. So you just link that one. Now on maximum, vice versa. So now on max, if that max condition, meaning the pump has to be run, so you go there, double click it, and then change it to on. Then I usually put down here description said on. Even off I should have say, but you know. And then on, max is what? The constant float is gotta be 100%. So I put down 100% and change the default value to 100. Unit is, it doesn't matter you put the unit or not, but you know, just put the unit. It's easy to understand, I mean, you know, just nice to organize it. Okay. And hold is the last value. So input side, I'll just put down speed only. So when pit loop tuning, we want to just holding last value. So output LV, and then whenever hold it, this is pump output is holding right there. And then control, we go to now control, oops, and pre-PID processors. So now space need to require more, and I'll just select it, bring it out, and expand it out. Yeah, who cares? Yeah. And then in control, select again, and then pit loop, right, the pre-process, and then PID. And then pre-processors, we double click it, because we are now controlling the water pump. So now this is pump differential pressure or whatever, and then PSI unit. Unit has to be matched with the process ID. And just a true, leave alone, and then hit OK, go there, and then here the water pressure is a process variable. Water pressure set point is a set point. And then minimum tune band is connected to minimum tune band. Process ranges, oh, hold on. Process ranges go to process ranges. Time constant, process dead time, and proportional band, integral time, and interval period, and then saturation time. And I told you that I will be give you my reference for the PID prac, and it'll explain what is the minimum tune bed, because it's, if I start doing the pit loop, it'll take another days, I mean half day. So, I mean, if anybody want to know more about detail, we can go for tomorrow. But anyway, present value go out the pump command, pumps output. So when it's a control, we want to control, right? So constant. I usually do, once I done it, I usually copy it. I don't want to, I'm a kind of lazy guy, so. Okay, just copy, Control C and Control V, and then drop it. Boom. Okay, so now we all done. And then, what else? Oh, yeah. One thing that careful about the pit loop here, direct acting. Direct acting means what? Yeah, increase the value, process variables increase, output go increase. If the output is a decrease, go to decrease. But a pump speed, usually what? Reverse acting, right? When process variable is exceeding set point, you want to lower down the pressure, I mean the speed. And when it's low, you have to go back up. So that's the reverse acting. So you have to come here, instead of direct acting true, you have to select the false. So reverse acting. Now that's all you need. And then, but you want to expose that the process ID, you can select the process ID. And you want to see what you want to expose that unit, you can select the unit, you can see it. and you can just bring out, say, unit PSI. You can set the pump, this is a pump differential pressure. So now you're all done here, and now all you have to do is this guy, select sequence connected to table. So now, oh, sorry, table. Did I put down the table? Oh, I didn't. Sorry. So go edit. Now I'm gonna just so state 0 to 3. And then I'm gonna adding also column because we don't have that one. So on the last column, I'm gonna have like a state, state 0, 2, 3. So now, once this happening, I want to 0. I want this happening is when it's 2 is hold, the 3 is control, and I am apply. Because all other cases, because it's not as dependent on to the handle unit, I just put, leave alone with all asterisk, meaning is a pass down. Don't care about with the, another, priority. So now only have to go there, pump state sequence, link to the state table. They'll say I-20, input 20, boom. Now show all, see here, it connected it. Now undefined, the last column, we have to link to where? Pump control. So now we're done. So now, see pump control. Oh, I named it wrong. So on the state table, it is right here. On connection is right this one. And then now water pressure. We have to link the water pressure. Oh, no. Did I put down the water pressure? Oh, why did I do that? Mismatch alarm. Pump interlock. And pump control. Why? Did I put? Oh, sorry. Water pressure. No. Okay. So I didn't put the water pressure sensors. Pressure sensor. Yeah, I thought I did. What in the world? So water pressure, I just adding it, and then range is 0 to 25, that's fine. Now pump control, I clicked at the water pressure, this guy, and the water pressure set point from the network input. And then output is actually, I will create the last value for the enumeration, the float, and then pump speed, output LB, and this guy link from, I'll get from, come on, my mouth, and pump control, pump output. Now, because this is, if I'm, there's no way that I can link to back to this guy because it's going to be an independency of the logic. That's why I create the last value. And I'm collecting from that pump control speed output LB coming back. So then I can control. Now pump speed, pump command here, and pump output. I am connecting to the water pump speed output. So it's all set. So now I'm saving. test the AHU fine. Now we're going to simulate it. Start simulating. And now if you go to the state table, so right now 0 is off. Why? Because this pump control sequencing is disabled it right here, shut down. So to enable it, we have to come down here, pump sequence, go to enable. Boom. And then now it's under control. If you go down, now you went to state 3. So if you come down here again, pump control, and now is in the state, in the control, water pressure 10 right now, and then set point is 10, so they are set at 0. But where the water pressure at? Water pressure is, if I command to say 0, and then pump output, water pump output, they go high, see already 98. So this fast, because the pump, there's a pump control pit loop, the speed is fast. So as soon as I see it, it'll just send out the 100% because it's 0 psi. But you know, just like testing out now, water pressure say, oh, this is exceeding now 10, which that is 10.5, and output will be dropping out. See, 91. Now I said, okay, just 88. Now I said, okay, now it's maintained at the 10, simulated, and then it'll lock out that, you know, whatever that the value last time sending out, it'll stay. See, the lock it. So now it is control at the 91.4% to controlling that pit loop, the pump speed, to maintaining it. So this is just, I just create crazy fast to create the one sample. But this is can be asking by the end user. Also, sometimes you can recommend it to the end user that if you have available points, and then you see some application that customer might have an interest, you can offer them. So that's a sale, at a field sale, we call. So creating this. So, but the state 0 and things, I don't like it because, you know, you have to specify backnet exposed. So usually I recommending using standard enumeration, because the standard enumeration meaning is it'll just, you know, matching up to all the, you know, enumeration, easily understanding it. But if you create your own custom, at the output side, it'll be come out because once that the backnet exposed, if not backnet exposed, it'll stay at the state 0 to 10 or 0 to 1, whatever. So let's create the one. Now we're going to leave this one. I'm going to disable, no, this one, no. We're going to create the let's say exhaust fan or relief fan. You know, of course it can be done, but let's just, you know, create a side loop for fan, relief fan. Relief fan control by that exhaust static pressure. So AI, whatever number AI available in the controller, we're going to name as exhaust pressure, right? And then in network NI, network input is EAP SP, which that is the default is equal to 0.01 inch water column. And then BI we have exhaust, relief fan status. And then we have a BO, which is relief fan command. AO, we have relief fan output. And we need to control that the condition is first is off. 2 is what's the enumeration standard for, hold on. Yeah, I just want to make a standard one so we don't have to create our own. So instead of dealing with the state 0, 1, whatever, that's, once you really get used to it, you can just manage it well. Otherwise, it's just to find that pretty close by, because you don't have to use all the, the enumeration. It doesn't matter. Because, why? Because of state table. You can only define the whatever unit it. Wow, it takes so long. No, I have maybe too many things to open up. Or maybe it's a broke. Yeah, I think it's I open too much. Open up too much things. Wow. What about? Come on. And off, on, off, off. Wow, what is it? Off, on, max. Wow. Hold on. What's going on here, really? Yeah, sometimes I open up the
Off on control.
Yeah, so off on control maybe. Off max.
Control.
Off on max, right?
Off on max is one, yeah.
Off on max. What about the control? Off on max control and hold. Do they have that one? Off on max control. Okay. Test HU.
Just off on control. Off max control.
Then there's off. Hold on, let me just got here. Okay. And instead of doing this one, off. Okay, off, on, control, and OVR. So this one is, what it does is just, I'm going to break it. Just break it. Yeah, that is off, max, control, and hold. Off, on, control, and then 4 is hold. And this enumeration set is off, on, control, and then OVR. You can select this guy. And then during the off, let's say, same thing, that the disable, enable. And then pump, mismatch alarm. And on is, well, we don't care much on right now, but a control the pressure, control the static, exhaust static pressure. And hold is when PID tuning. I want you guys to create the one, this side loop. And try it and raise hand. If you need some help, I'll stop by and help you out. We're gonna do this a lot. Tomorrow is gonna be most like this. So you guys are advanced classes, not our basic classes. You heard that, the gentleman told me that Thursday, I have another class on New Jersey, Fairfield. They said they're all basic training, so that's more painful. But yeah, let's try this. Oh, yeah. Okay, so I want to make another condition. When is on, meaning is when water pressure sensor is unreliable. When water pressure is out, then we want to put the condition on. I'm going to let the pump speed to the
Building pressure, you mean?
sorry, static pressure. So I'm going to, in these cases, I'm going to run fan speed at 50%. I just extract, just created it once, so, but you can try. So now it's 129, so 130, so let's see. Whoever done it, please let me know. Yeah, this one is right here. Usually control off, max, control, and hold. So in future, you guys, you're going to use a lot of these enumeration set. Off, max, control, OVL. OVL is override, which is hold. Well, just like, yeah, be brave. Yeah, you can just put on the top there, top of my computer.
I don't have USB. Oh, what is
Oh.
it?
You don't? Okay. So you guys from that all different company, right? Good. Yeah, go ahead. Grab a seat and then just, just guiding us how you done it. That's great. Can you send his boss that he's the first guy? Volunteer.
All right, so I created a sine loop. Left it out there, had one network input, first acting, created a state selection table interlock, and went from there. So I added my set point, or renamed, we had set point, fan enable, pressure, status, the output. So the first thing I did was create a reliability check. So if exhaust air pressure is reliable, then I have a toggle, a network or an output there. So I used that to create a state table. And if the reliability is off, I send the PID to max. And then under the PID, under the max, the constant I changed from 100 to 50. And then I went and did the fan alarm. So this is my fan alarm logic here. Looking at fan enable, fan status, with a little bit of a timer. So I got a 5-minute timer on it. So I use that in the state table as well. So if we get a fan alarm, push the PID off. That's about it.
Right. It done well, and especially but the fan alarm, I usually put into the set point miscellaneous.
Yeah, all my custom models I always put in.
Yeah, it's just fine. It doesn't make it. So if you did the straight that way, just keep it that way because you know that.
Yeah, and then I just have a network output just so that
Yeah.
I can see the alarm.
All right. Awesome. Well, see, it's like he done his way,
Correct, yeah.
and so his way is nothing wrong. And anybody else has a different idea.
There's many ways to do it.
Yeah. Thank you. Thank you. Yeah. What's your boss number? I can call him. give you a raise. Big raise. Anybody else? Yeah, we need a more different idea because he done different idea than I usually do. So now I pick up something that, oh yeah, that's a good idea too. So yeah, just don't be shy. Just share with us together. Because I'm telling you, every different program, it doesn't matter, is about the HVAC side or refrigeration side, any program, they are all dependent programmer. They are different. There is nothing we can say that's not right. There's always different way to do it. So I think it's mostly I think it's that you guys are still maybe working on it, and then maybe done, and you don't want to share with us because it's a high secret, and you don't want to keep it hide. It's fine. And I'm gonna share mine. And what I done is the same way that I done before. So on the pump sequence, I put the pump sequence shut down and enable from the network input. And then mismatch alarm, I'm just create the pump interlock at the state table right here. And then I kind of a reliability check is a slightly different way that I throw that water pressure sensor input into that sequencing logic. So in sequencing logic, what I done is when I still using the command hierarchy, that is when is command shutdown, off, no matter what. And then when enable, and then my interlock is alarm, mismatch alarm, and I want off. When enable, and then the interlock is normal, is going under control. Now, I could have done the other way, or one more, but what I done is I just put the water pressure, reliability check, and then reliability check is go true, then it's go true, but I just could reverse it. So when it's not true, then when is, if this is a false, meaning is a reliability go fail, then this is going to be a trigger to true. So when water pressure is unreliable, I create in the state table, and right above that, the pump control, right above it, I said, when pump sequence water pressure unreliable, if that go true, I want to go max. And if this is not, pressure sensor is reliable, has to go down. The next, what I said is like a pump sequence when go off, max, control, hold, and do the whatever it's supposed to do. So this is another way. So either way, interpretation, the way the program, sequence or logic might be slightly different. It is a way different, but the result is the same. All depend on, how you handle. The gentleman said it's like whatever he created his own custom program, he put on the output control side, fine. That's fine. Keep consist on it. But my way, I always put the, all those mismatch, changing stuff, I put on the set point miscellaneous column. So that's my way. And then your way can be different too, so it doesn't matter. So pump interlock is I using the primitive module, which that is, I just select the command from that pump control. I have to create the line B, but I see independence right there. I have to create the pump, last value, enumeration, and pump, command, LB, okay. And usually this is a control status, so we have to change it to off and on. And off and on. And then I can select this guy from pump control, command, and my pump interlock, command, pump command LB, and then status, I can select from actual pump status. And then output delay 30 seconds, loss delay 30 seconds, and so on. So anyway, yeah, those things. Same way, but pump mismatch alarm will be linked into the pump control sequence. So there's many way. There's many way. And so this is another good example that we can try. That is, instead of doing this, because there's a primitive, we don't know how they programmed it. So now we're going to create the second sample called, say, pump, same pump, mismatch alarm determination. That's custom. I want to build logic that pump mismatch. So Pump mismatch come with when pump. So command not equal to status, sorry, backward. Status not equal to command for 30 seconds. Then we're going to call this is, when that's happening, is called pump mismatch alarm. Let's create this custom module. Because there is there, but still, it is primitive. And it is working, but you don't know how it works. So that's why I say, just let's start making this one. Because you have to make this one. And then after that, we're going to make a strike, 3-strike future too. So, yeah. So to do that is you need command. So pump status, BI, pump status. Yeah. And then in the logic side, you just need to, just LB, command LB, whatever. That from that, using the same logic that you just built up. And let's just do this one. The gentleman already showed to you guys, so should be simple. And then whoever done this, try adding future here for 3 strikeout future. So when first initiated, alarm initiated, and give him a time for minute, and then check again, and then if there is alarm, then you count now that the second strike, and then give it 1 more minute to recheck, and then if that total 3 set strikeout, then you lock out at the fan. You don't have, just make a logic only. That's all. Because I just, tried you guys to get familiar with the timer. And then timer latching, latch module. Is anybody done? Then he can come out and just show it to us too. Because the last one that we done is a pump control is, see here, pump control. Is pump control actually sending out that the actual output to pump command and pump speed. And also I sent out that the pump command to the LV, last value, for enumeration. to try to avoid independency circulation for pump interlock check. So same logic that just to check, easily check is a pump command LV compared to the status. If they are not matching for like a 30-second, then you can just set the alarm. Very simple. Okay, so hopefully that you guys all done. But I just to create that custom interlock, device interlock that you can apply for fan, pump, anything. So command status, comparing it, I using the command hierarchy. Why? Because it can be a, sometimes I don't want to condition to say that the fail true when its command is not on. So only I condition created is when command is on, status is off. Then if that happen, that's the only true trigger. All others, star meaning is all other don't trigger. So that that's why I just create just command hierarchy. Command hierarchy output for the Boolean. That is under selection, and then here is a command hierarchy Boolean output. And this one is actually this one. So when that trigger, when command is on, status is not on, status is showing off, for time on delay, I put the time on delay time for default to the 30 second. Usually, typically a fan, 30 second, pump is all depend on. Sometimes like a pump, they want to like put down the 15 second, but the 30 second is not bad. Just 30 seconds all default. But if you do with some refrigeration side, compressor, usually faster. You need a 5 second. Sometimes they just maybe allow up to 15 seconds, but they not allow for 30 seconds because it can be a damage to the compressor. So I defined the alarm delay for 30 seconds, and then my display precision is 1 only, because that second is just we don't need tenths anything, so no precision at all. And so whenever this is happening, I put on the top that when they go true, that is go to show the alarm. That's actually a translation from Boolean to enumeration. So when command status mismatches for 30 seconds, still mismatch it, then I'll say this is alarm. That is mismatch alarm. So once mismatch, but after 30 seconds, it come back status on, then that mismatch alarm will be disappear. But I mentioned about that sometimes there's in specs that if that happens, some specs that is if happening, lockout. And operators are supposed to check the unit, and then they have to reset to release that alarm. But sometimes give a maximum three attempt with the interval with 1 minute, and then release it. I mean, if they're still max reach out 3 times for interval with 1 minute, and still, it's adding up to 3 strikeout, and they want to lock out. So it's all depends on the sequence, on spec. So what I done is I create whenever the first time hit it, the first strikeout, here is the first strikeout, is a time delay actually. It's the latch, this is a latch, but I just named that the first strike, but this is actually inside, this is a latch alarm, a latch one. So when is the latch? So when first one is happening, it'll latch. And when it's a latch, this is a strike 1, is a constant value, and then it'll just pass the 1. It'll add it, because it's a strike, latch it, so 1 is there and coming in 1. And only that 1 is, it'll be go to 0 when you do the reset. Otherwise, it'll stay 1. Now, next one is happening after interval duration 1 minute. It happened, and it goes to second strike. Same thing, second strikeout, a lockout. It's a Boolean. This is the latch lockout. When they lock out, it'll go to the strike one, adding one. So one is coming back here. So now 1 and 1 second is a 2. Now 3 strikeout is how to determine it is once this is happening, and then wait after second strike. Wait for another minute, and then if that is still strikeout, then I'm sending out the 1 again. So 1 here. So 1, 1, 1, it'll set. And then go to here, compare it to whether greater than or equal to maximum strikeout. I define the 3. Then I'm latching again. So once the latching, now instead of pump mismatch, now this time is a pump lockout. Pump lockout will be go alarm. Then in that happen, we can just shut down the pump sequence totally. And then, of course, it'll be send out the alarm. You have to be defined the exposed to the backnet exposed, so you send out the alarm. And then when they checked out, everything's now they fixed it, whatever, then you have to be reset from the network input side, reset it, and then just back online, just rechecked again. So this is actually interpretation, another way to interpret that our equipment interlock primitive module. Our primitive module is the same this way. So, yeah. Just you guys can see that this one through your Teams SharePoint. If you like it, snap and just snipper tool and just snip it and just save it. I'll try, send out, whatever we've done in it, but, just like, who knows, maybe you cannot locate it and just, snapshot this one and then just, save it for future. Yeah, it's just, see, it's a custom program is really kind of a, just like, now you know how to handle, you know exactly what's going on. Primitive, you just see result, but you don't know how they process inside. So that's a big differences. So blind points and the C point is totally different. So.
Can you show us how you set up that first fan hierarchy?
Which one?
The first one there.
Oh, fan hierarchy, sorry.
No, yeah, that one.
Yeah, so fan hierarchy is like I said, input 1 is actually command. Well,
yeah, I'm having a hard time getting that to show up, that input 1 and 2.
Yeah, yeah. So input 1 and 2 is right here. So input 1 is actually command, input 2 is a status. So, but if you have a difficulty later on, I'll just say, okay, CMD, just an STS. Right here. So command, when command on, when status is not on, then I'll say, oh, this is now trouble. Trigger the mismatch alarm. And all others, I don't care. When fan command up, fan status is on, who cares? Because it's not commanded it. Maybe just, But really, sometimes like a spec set, both way. If no matter what, command and status is not matched, then set the alarm. Then you have to put the you have to put the other way, which that is, now you have to adding one more, that is like off and on is also true, and all others go false. This one is now how that command hierarchy do is whether command and status is not matching, no matter what, then they set the alarm. But first one that I did it for without the second one, meaning it's only trigger when command is on. So that's the different one.
Could you do an enumeration outpoint?
Yes.
Output and
Yeah.
then say, that's like the first line would be a command fail, the second line would be a in-hand fail? or
Yeah.
something?
Yeah. You can just create So this, I create this one because I want to do the 3-strike checkout, but you can create enumeration output to command hierarchy to enumeration output here. Oops, sorry. Then delete, because default is always a Boolean, and you adding input. Now output condition is going to be different. So let's just first of all, the gentleman just asking about that is that specify that the condition of the failure. So when command and then status and then okay, that the state, the output state. Command is off and status is off. We can say normal. And then when it's on, normal. When it's off and this is on, then it's yeah, it's just in hand, whatever, yeah, in hand, and then on, off, say mismatch. And now we have like a 1, 2, 3 conditions. So state 0 to 2, because this is a custom sum. To do that is we have to change that output side instead on and off. There is just to see it. If do we have something else? I never see that, but yeah. Well, there's a normal short open, but let's just using the state 0 to 2 and apply. Now I say C1 is we just put the even description for the input, so we'll know it. Yeah, STS is fine. When command is up and this is up, we say normal, state 0. When this is on, also state 0. Now adding law is an insert law, and then this one is when is up, when this is on, we'll say state 1, which the state 1 is in hand. And then when is on, when is up, we'll say this is mismatch alarm. And then apply it. And then you just connect this one, and then output enumeration, put it in here. And we're going to say this is, say pump, whatever, pump, yeah, pump, pump condition, whatever, just. And then we're going to say state 0 to 2. And then I'm going to expose the backnet. And change that. This one is normal. And then this one is in hand. And this one is mismatch alarm. In this case, now you got even more specify the alarm status. So now we can simulate it. I'm going to command C here, state 0 because it's off, off, now normal. I say command is on. Command is off, and the status is showing that on. Send out. See state 1, in hand. Now backward. Now status is going to be just restored to off. Now back to normal. Now command is on. Now mismatch along. So yeah, you can do whatever you want to do it. Just like enumeration is sometimes we do have a standard enumeration when we don't have it, and you want to put some specified at the detail message, then you can create your own state enumeration. So using that the state 0 to 1 through 0 to maximum is what? Hold on, let me see. I see, yeah, it's a lot. I mean, it's a lot, but I cannot remember. It was a lot, but we'll see. Every time I run it, and then it's just shutting off. Maybe this is caused by all others. Well, anyway, just I have to bump up again. I don't want to wait. Oh, no, it's not. That's second time. Oh, don't tell me that. Don't want to see that. Test. Because every time I connecting to the third-party internet, because our John's Control IT security always checking something, so just. Okay, so now back to again. This state is maximum, I believe that is 12, no 15, sorry, 15. Meaning it's 16 different enumeration set you can put it in. How? Is it possible? Yes. I see guys that put all 15 different types. I was like, that was a refrigeration side. I did it actually. When I was working with Hussman, the rack control with our controller, which is the peak controller using same CCT, and then we adding another embedded software. So, but still basic. I have using the CCT to program it. But on the refrigeration side, they do have all weird condition. They want to define it. Low pressure, high pressure, but like super high, super heat, low super heat, high super heat, and suction, discharge pressure, and they lay down like a long list for the enumeration. But CCT designed for the HVAC, not for the refrigeration. So I have to create every enumeration set for the refrigeration. It was pain, but because the first time that when I worked with the Hussman, and I have a basic principle knowledge on the refrigeration, but those guys are really, just guru on the refrigeration. It was fun, but it was a pain. But anyway, this is happening, and then sometimes I have another tip that I already told you that because in command hierarchy, if somebody click and open up, they have a 0 to 2. What is the hell is it? 0 and 2, 1, 2. And you want to put it in using the text mode. And then text mode is output state. And then I say state 0 equal to normal. And then state, I copy it. State 1 is in hand. Copy it. State 2, mismatch alarm. Now, you put this nicely, put on the top, then in the future, even though you are not at the site, or another person's coming in and he will understanding what is this meaning is. Because he can just look at this guy and say, oh, yeah, Upper State, he did it. Oh, yeah, very nice, you know, then he'll understand it. But, you know, once they're running it, because we exposed it, this will tell you. But when you troubleshoot, like some, you know, some other person that you may not understanding inside, and, you know, what is a state 012. So that's what the text, you know, text box you can use it. And then, yeah, the other feature is like, it just is a basic feature, just, you know, triggering and stuff. So anyway, this is another way to do it. So instead of using that, you know, primitive equipment interlock, but primitive equipment interlock is pretty basic. So just, you know, don't bother, just use it. But if you have a very specific, because I use this one, not only this one, but I use this one for the refrigerant compressor protections. And they have a little bit slightly different way. They, you know, not only status, I have to put the, you know, pressure, and then suction pressure and high discharge pressure. Make sure suction pressure is lower than, you know, 5 psi. They want to lock out within, you know, 5 seconds, whatever. And then wait for like 30 seconds, retry it, and then, you know, it was, that's why, you know, I have to use this style. And then kind of explain to the end user, because I have to give them a solution and software so they can, you know, just, because that is, PIC control is a little bit different. Once we program it, I'm using another software to compile it, and then they can put in the thumb drive and they can just plug into my PIC controller, done with it. They can, in the factory, when they're manufacturing, plug it in, go, plug it in, go, that's it. Because in the factory, they don't want to, you know, bring out the computer and, you know, do the, you know, on the manufacturing line, you know, there's no way. And so they said they want a USB solution. That's why we actually developed the new controller. It's the same shape of the, you know, FAC, but the color is a green in the front. So that's another way that the US thumb drive things. So yeah, we actually done a lot different way to meet the customers, you know, requirement. M4 series is for the branches. F4 series for the, you know, all the direct channel, indirect channel. And then now we have Easy I/O, that is inside, outside, everybody. It's just, you know, that's the open source controller. I'm just surprised that what's going to be next.
When are they getting rid of CCT?
We were at the right after CCT release 14, we were talk about it, but we just stuck. You know, I said, forget it. We're going to stay with it, because the meaning is like, then we have to change the whole production line. I mean, entire engineering team and software development. Cost is way. I said, stick with it.
That'll be around a little while.
Oh yeah, I bet you another maybe 10 more years. But they will keep maybe they will keep build the more primitive. So try to, you know, minimize the, you know, customer time. But we know the world, you know, because once you get into the field, always they require some custom program. But you know, as you know, there is like you already know that how to use the side loop, so easy.
How about copy paste for inputs and outputs?
Yeah, well, that's very another my expectation too. But are you guys using it? What CCT revisions you are using? Mine is a 15.
Yeah, I'm at 15.
Yeah, Are they changing yet for that network sensor from NS7000 to NS8000?
Yeah, I believe so.
Yeah, because I'm still have to, defining network sensor from, because it's, when you selected the network sensor in Q&A, they dump out, oh, not this one.
Oh, I'm not sure about Q&A, but it's in the design hardware.
Yeah, Q&A is still with the old NS7000. So what you have to do is make sure if that is using NS, yeah, see here, the small icon right there, that John, that small icon with Wi-Fi in a streak, that is NS8000. But when you Q&A selection, they dispute out that just regular standard network sensor shape, that is NS7000, old one. So you have to go to the define hardware, and you have to adding devices and select the NS8000 and hit OK, and then come here, changing old one, changing name because they're all same. So changing name, the old one to I usually put on the at the back that I just put old, and then changing old connection, and then delete the old one.
So is there any negative to using the 7,000 or the 8,000?
Well, because the 7,000 is now going to be obsolete.
Well, I understand that, but I'm saying like in the software.
Yeah, they are different. The software is, the protocol is slightly different. That's why. If so now let's say file.
Yeah, I'm going to probably go out on a limb here and say that we probably have.
Here's like another one, test VAV 1, VAV, single dock. I'm going to leave as a standard, whatever. No, nothing's here. Oh, humidity and CO2. And then next. Let's finish it up. Ba-bam. See? Yeah. That's the old. So now you have to go to define hardware, adding devices, NS8000, boom, and carbon dioxide, and humidity, and zone set point. If there's a warm-up, cool-up, you have to set one of the, one, because you have only one select. You can do whether warm-up or zone set point, which there's analog value. And then adding devices. Now you got the two of them. So now, what I'm meaning was, select the old one, zone temp. Old one. This is old. This icon, without the Wi-Fi or bigger one, is old NS7000. See where they linked it, but the same name. So I usually do is like a changing. On the back side, I put old. And anything there is just, I just put old. Zone humidity is don't care, but still let's just consistent to do that. Zone Q, it's okay, just leave it, but we can change it later on. So, go to zone temp, old one, and there is a many of them. And if you cannot remember all, I always encourage you a snipping tool, select it, and just grab this one so we know where they're connected to. And then just keep changing it from proportional box heating, process variable is a GNT old, change it to, why mouse is bad, GNT. So now this guy has now already connected there. So just do that. I know they are working on it right now.
What's the downfall if you leave it at 7,000?
It's not going to 7, if you put in the 7, 8, and an NS8000, it's not going to communicate it.
Sure
They do?
Every job we've done since the 8,000s have come out has been the old way.
Really?
Yes.
I've never changed it.
Yeah, it still works, but you're just gonna be not having the additional functionality you get in the
Right.
like you have all those extra options.
Yeah.
8,000.
Yeah.
That's really it.
But I am encouraging to using that the NS 8000 and changing it.
Well, I understand that now,
Yeah.
but I don't know that Johnson's ever sent that.
I know, because it's now it's like I went to the Midwest, channel, same class like this. Everybody just like, when you guys gonna changing that, that icon to, automatically go to switch to NS 8000. I already told our firmware team software firmware team to changing it, but just like,
But it should be in the selection, you should have the 7,000.
I know, but just like they will do it. Maybe sometimes next release, maybe, hopefully. So we'll see. But meantime, I understanding is like functionality wise, basically VB boxes are what we're using it, temperature and set point.
Correct.
But if you're using the more other things, like we have to just changing it. So, yeah. Yeah, it's like, myself, that is like I've been kind of away from this NS 8000 because my OEM customer side, manufacturer side, they're not using, that network sensor. They don't deal with the network sensor. They deal always with, sensor, platinum, and they don't even use LTD. They're using usually just, thermocouples, those things. So I never really realized it until I start back to, training that the CCT, and then, yes, I found out that there's still things to do by the Johnson, software team to kind of give another selection at the, tree, whether it's Jones sensor is Jones Steady is NS 8000 or 7000, whatever. But 7000 is going to go obsolete.
It's default to 8,000.
I know, we're going to be, that's why I've just told them default to this NS 8000. I've been told about 10 months ago, and hope they're doing something. So that's another, things that I even got from the field people, that just like, not from branches. I got from our channel distributor. People says like, hey, when you gonna change it? I was like, what do you mean what? I didn't know, honestly, I didn't know. Because nobody complaining. But they're using this, just like gentleman says, like because they're only using the John set point, or warm cool down. So they never really bother anything else. But there's many many feature like fan speed request and those things. But are we using for that many? I don't know.
You have to do more with the new display one.
Yeah, DLK. Now, oh yeah, that's good. Another point. The one that I mentioned to last time was a DLK 350, DLK 0350. This is the new replacement of the DIS 1710. This one right here. How come don't they have like a good pictures? Here, catalog pages maybe. Yeah, this one. This one is a new display. You can be installed in the panel, or just handle. You can just bring around and plug it in and see it. And then all this display is depend on to how you set the display at the CCT. So yeah, that display is finally that at least we get the shape of the real display. Because DIS 1710 was long, and then only 3 line was it. Oh, forget it. So, but this is decent. It's okay. Cost-wise, is decent. But display is expensive. Every display, like over 4 inches, they're too much. Because I told you I'm dealing with a lot of OEM side. Every OEM manufacturer, they want a display. Air handler unit manufacturer. Oh, I want to put the LCD, nice color, graphic, so on. and we give them a price, forget it. Because it's still, it's not a Johnson product. So we only provided the solution on the embedded software, but the display itself, I don't know why it's so expensive. So, okay. Oh, also this gentleman was mentioned about that trick. I didn't know. You guys knew that? It's right here. See that this gray spot here and this one? You double click it. You can just pop it up. Double click it. Double click it. And just instead of using this, guys. So that gentleman over there, he told me today. I didn't know until he mentioned to me. So you want to expand it out. This one, just go there. This gray bar here, and double click it, and it'll just expand it out, full screen. And then double click again, it back to normal. Now you go down here, double click, and then it'll just expand it in a feature, screen. I mean, feature, a feature block side. Pretty neat. Thank you. Why? What a handy. When I was in a hurry, I usually hit the maximize, and sometimes I hit the minimize, and I, just another 5 seconds that I have to, wasting it. But this is good. And the side loop is here. So side loop, and here see that the input type that we were we already done with the pressure and the static pressure stuff. So you can use the other and so on, but you can use this one, or you can use yourself that fully customize it. So it's up to you guys. It's never, there's no limitation in CCT. There's no rule, mandatory rule that you have to do this way. No, there's no way. Sometimes you don't want to use the state table, then don't use it. If you have an on and off, too simple function, then you don't need really a state table. Like a state table is good once that there are control module involving with all different priority, that is good. But simply only just do the on, off, then you don't really need it. But every CCT program that you create from that selection tool, they automatically build up the state table. So that's why you have to really understanding how to read the state table, because the ability that the reading state table is actually helping you to troubleshoot while commissioning the unit. And also, let's go back to again that perspective view is we have a two, classic and simple. When you're commissioning, especially VAV boxes, stay with a simple view. So one screen, you can just see it instead of just here and there line and module and so on. And if you want to see more parameter side for the more backnet exposed, more feature, then you can go modify whatever that auto calip right here. Say, go double click it. Now, that O2, whatever that is now not showing it, but you want to see it. Hold on, let me just back up again. Auto calibration sequence on the parameter. See, state generation. Auto calibration sequence is only auto cal state, right? Now you go in here, you change this one to true. Auto calibrate now. Right now only this is true, that's why it's showing only this one. Now you apply it. See, right now, it's now next line is also gonna show that whatever we just enabled it. So if you need to see that the more internal state condition, just go there temporarily, backnet, expose. Then it'll show into the parameter screen. And once you've done it, and when you do the commissioning it or do something that troubleshoot, kind of in a hurry, go simple view, and then you will see all the input value. It'll be showing up. and then you will see that how they do, what they're doing at the set point. Plus, we don't much concerning about it, but the state generation side. We know what state generation now they are doing it, and then we know what output control side we're doing it, and then output. So one screen you can tell easily, just kind of I say text style. One screen, one eye, you can see all. So that's another beauty. And yeah, people asking about the trunk utility, meaning is massive download. So yeah, it'll take longer than it used to be. I know, so a lot of people really hate it, but I don't know. It's like, is there any other way to do it? Is anybody has any alternate way to massive download to saving time? Yes.
There's a new application for it, the APLC, Application Parameter Loading Tool.
Oh yeah, I never used it. Yeah, I never used it. But
Yeah, it's really nice. It's buggy, but it's nice. They had to customize every time you want to use it, but it's nice.
oh really? You cannot save that, when you're
You
the.
can, but then if you got a different type of cat
Oh, okay,
slightly
okay.
different parameters, you got to redo them all.
Oh really?
Yeah. You can jump between site to site. Yeah.
That's.
I would say that it's a pretty good basic tool, but it has a lot of room for improvement
Yes.
and usability.
Yes.
Like, there seems like there's a lot of functions on there that should be pretty standard, but like, it can be like pulling teeth sometimes.
Wow. Yeah, please, that, the recommendation improvement, please send out all those things, to the Brody Precisions, and then they can grab it, and, they can kind of gathering it, and they can just, send out to Johnson. Yeah, because it's, without the feedback, we wouldn't know. Because branch people, we are just, kind of teaching them, so they just, they really don't care much. I'm not saying care much, but they just kind of get used with it. But, on your side, if you can save time, or you have some kind of a require maybe more improvement, please just raise your voice. Why not?
So improving the 13-minute download time would be great.
Don't just. I told them I told them like how many times. Is there any other way that we can do pushing out that just. I know. That's why I still like the NA point schedule. NA point schedule was really nice that we can using the spreadsheet and then define all the trunk number and everything, and then define the type of select the CAP file. Then they can massive download it at once. But that feature is gone because that the new protocol, new format inside of the CCT, after CCT release 10 or whatever, they are totally kind of changed out that the inside the structure of the CCT main code. That's why we cannot use it anymore. But we are improving. We are keep improving ourselves. But when we don't hear that any voice from the field, we think that is, oh, this is super. Now everybody will like it. So you just keep stay on it. But if we have like a feedback, then yeah, they have to be kind of improve it. They have to really pound it, improve it. Because the management will have to listen. And yeah, this is magnetic exposed. And advanced already dimension, C table. So we cover today is a BAV. I hope that now you guys have very comfortable with the VAV. You're already comfortable. So, but now fully kind of you can get the imagination about that state table, sequence, and those things. Any questions about the so far? Or it doesn't matter. This, as mentioned, that Tom mentioned, that this class is not has like a standard, just like agenda. Your voice is all agenda. Tomorrow, I already put down here, We're going to do the secondary chill water pump speed control. It's all custom. Custom economizer. I like using custom economizers determination. Whatever we have right now, FSM, customized, economizer determination. It's okay, it's working, but now in a field, actually, I adopting this one from that my development for the EGIO. So this is another good feature we can try. And then occupancy mode, why not? And zone 10 set point determination. And then tonight, I'm gonna keep getting more things so we can list up. So tomorrow and then Wednesday, we're gonna fully kind of, do it by yourself. And then please share, whenever you've done it, please share with us, because that's the great point. Think about it, it's like how many people here, if you guys built one person at a time at the, like a job site, you found some easy way to do it. Not only module, not only program, maybe define the simple view for the VAV or annual unit, share it together. That's gonna be really a lot of saving time, plus that make life easier for everybody. And I always willing to share with people, because I used to have like Dropbox, so they can pull it in, they drop, take it out. But since after I leave that operation for the branches side, I don't use it anymore. But feel free. And anybody have is it you guys are still using a lot of a rooftop unit, right? Commissioning a rooftop unit. Are you? Oh yeah. And are you guys handling with like a dual compressor or a full compressor package? Yeah. Sometimes they usually rooftop units come with a controller, so you don't have to worry much. But sometimes they are coming and then you have to maybe put the controller. Is that a cases?
Well, to be honest, we've probably gutted more Johnson units last year than like factory York, ripping out the SSE boards. And
Yeah.
putting our own in. Nobody likes it.
Really? SEC board. Can you raise that, boys? I already working with the yoke. That how about using the EGIO or F4? And yoke is different animal, so. But just like they stick with the SEC board.
But the Dykins and the trains, they're harder to do because they pretty much can't, because they're controlling fans over Modbus and
Yeah.
things like that.
Yeah, I offer them to EGIO because EGIO can do the, as maybe some people know that BACnet Modbus simultaneously. So, but I'm still working on it. And SEC board is, that's I have to really kind of I've been asking that why don't they using for the F4, M4. But you think that is SEC board has more demand because of nobody complaining maybe? I don't know. But branch people, they see the SEC board and then they start they say there's a lot of difficulty. I don't know what difficulty is, but they say there's some difficulty. So they rip it up themselves and they put the FAC or now it's like a CGM.
They might be fine, maybe it's just the guys setting them up.
Maybe, yeah.
We ripped quite a few out.
Yeah. Usually it's all depend on who's setting up. So, but yeah, when you see those things, like when you see need improvements or replacement or something, just raise the voice. We hear actually, we are hearing it, but when we don't hear, we think that that's everything is fine.
Yeah, so the map gateway.
Yeah.
Or this thing, it is all over the community about not working with the power settings.
Oh, really?
And not everybody's laptop, like even Frank can't find it on his Dell.
Mm.
We can't disable that. And we can't upgrade the firmware in the maps that we have you have to leave it plugged in.
Oh boy. Map tool.
So this one's not any better right now.
I don't know, like a map tool. But you already got this one. So yeah, this one is, I tested it, it's working fine, but we'll see.
Well, that's the one I'm talking about.
Yeah, yeah, but just like, oh, this is, the CWCVT, whatever it is.
Yeah.
Huh, that's where. Yeah, and if you have a kit problem, you got my email address to send me, then I'll just talk to them.
They have like a flash sheet out that wasn't published.
Oh, really?
Yeah. So
Ah.
somebody put it on the community.
Oh. Well, but somebody have to really do work on it. So then, maybe somebody have to pound that the specific person that I know, that person. So. Okay. How about the heat pump? Are you guys, doing a lot of a heat pump? Good. And heat pump, I think this, in Europe, they already start touring to the heat pump from the, a rooftop unit. Now they start, tore down to the heat pump.
Probably better.
Yeah.
We've had a lot of trouble with the MSC block, so I don't know.
MSC block is, that's what I'm saying. Like, if there's a 4 stages, the lead lag conversion and those things, I usually use my custom program.
But just a single stage heat pump, they don't control very well.
Yeah. So that's why I don't depend on the MSC sometimes. It's all depend on it. That's what I'm saying. It's like, if you have that kind of a situation, if we knew, I don't know, we know about it, but just like, I wish I know that where is all the boys coming in and who collecting it. I don't even know, but heat pump side is like a stage. I mean, just like staging. Up to 4 stages, I can handle it. But after 4 stages, guess about it. 4 stages after that is like 6 stages. The possibilities are too much that I cannot program because it's too much. Too much is space needed. That's why I actually request not outsourcing it, but to my case is outsourcing because it's still internal Johnson, but I am using some other teams in India to develop the staging up to 12 staging to different way. Once that's done, that's for not for this M4, F4, this is for the EGIO, then I can maybe adopt that feature into the CCT. But up to 4 stages, yeah, I don't have it right now. I have it in an EGIO side, but I can convert that to the easily to CCT side. So that exactly know what is lead, what is lag. Right now, MSC doesn't tell you. It just do by itself.
So the whole pulsable and non-pulsable.
Yeah. And then, just like output is you see that they increase it, but the inside, I mean, they actually do nothing because we are using not output. Actually, we are using Bernoulli output. And I said, why? And that's the difference. And then did you ever see that helpline? I mean, that explanation of that MSC?
In the help file?
Yeah, I cannot even understanding myself. It's like, what is this? 5 ton, 10 ton, and then there's like a processor. It's like, why they make it so difficult? So that's those things, yes. I am actually will be working on it. When I'm done, I'll send out to Precision for the up to 4 stages. You guys can test it. I mean, I'm only sending out when it's validated. Then, when validated, you can test it. I've been already using my custom program in different program. I already applied it and it has been validated with the data center. They liked it, so it's working. But only matter is now convert that to the CCT is just a little bit time. Yeah. Good to know. I hear that now already several times, the same scenario about the MSC. Good. I don't know, Because the last time I went to the Midwest, like a Chicago, Chicago customer and then a Wisconsin customer, I spent one day for the MSC. And they still, everybody just like, still, kind of doesn't feel good. They say, it's like, oh, well, why is that, using that way? And then I wish I know. But, only I can just translate it to, some common sense knowledge way. But still, yeah, I understand what you're saying. Okay. Any others? Any other things that you want to talk about it? Are you guys commissioning the FX, the Jace? Oh. Yeah. If you have a question, you can send an email to me, because I have another expert guy on the FX side. I'm not really expert on the FX side. I can answer it any question about the Metasys side, but FX side is slightly different. So, because that's the third party, I count as a third party one for the Niagara side. I got the certified, but just like maybe you guys better than I do. So, yeah, that's the Jace. I still have that. I gotta figure out Jace. FX workstations. Sometimes mine is work, sometimes doesn't. So. So close it. Okay, so now go to heat pump. You don't even have any, what is it? Are you guys commissioning the central cooling, the chiller plant and those things? Yeah. All right. Are you guys using this CAM program? Yeah. Oh. My case is I use maybe once, but mostly they require all full custom program. But it's, usually that's why I put the ES2 as like a secondary chill-water pump speed control. That's mostly we are facing with a pump speed control with bypass valve and so on. But just like a central cooling plan and then simple cooling plan, I don't know. I see that the medium size to small size, maybe they're using it, but mostly my project was a main chiller plant, like campus chiller plant, so I couldn't use well. But a heat pump is now these days people coming a lot asking about the heat pump, so we are now kind of this is all this, this heat pump selection didn't change much from the release 10, whatever. That's still, but we will be improved, because in Europe now heat pump is really kind of a big boom in Asia too. Because they are now like using the compressor instead of heat source, water source. We can think about that. And yeah, heat pump is, to me, that is more simpler. But same things. Once you're staging out at the coil, what is that? So coil and filtering. One, not this one. Oh, I'm talking about something else maybe. Two compressor. Yeah, two compressor things. And this one. I'm just try to looking something that just with kill the show time, See, MS stage compressor 2. There's a stage 2 compressor one. And then there's the MSC, and the MSC now is getting from this logic. And this logic has been sometimes confused the people because they wouldn't know which one is a lead and lag. And so, I mean, sometimes you have to define, I mean, sometimes the customer want to using the manual override for the lead lag order. And that's why I created a custom program. You can try also create your custom program too. Try it. Yeah. So there's a tangent point, only 2 inputs. Yeah. It's compressor control, and then reversing valve for the student. Oh, hold on, let me see. I got. This is one that I mentioned. This is now like an air handler unit, mixed air single duct. I mentioned about that why we care about that the duct static pressure if when we do not have it, and those things. So yeah, you can create your own if you feel is better, because this FSM is just. Everybody just like, this is like internal style, and only we can see that the flow, how the logic is working at FSM. But this stuff is not bad, but once you go to like next one, which one is it? Occupied sequencing. This MX. Mixed air single duct FSM. Don't they have it? Some of them they show, but mixed air single duct. Oh, they don't have it. Anyways, yeah, some FSM they not showing on a floor. I thought they do. Where is it? Here. I mean, I have a lot of questions. I mean, I have a lot of kind of complaining from the end user. Why? Hey, this outside temperature, whatever, now the economizer is enable. But sometimes your occupancy, mixed air single duct occupancy, this one logic is throw out like, kind of weird state. And I mean, don't you, those kind of things. Did you ever have any complaining or yourself? Because this one is inside that primitive, that the FSM function module that is pre-programmed by the, another software tool, we embedded it. This is how they do it. But sometimes we don't have a heat exchanger, we don't have a reheat, and they're all there. Because this is not only for the southern type, I told you one type. We are just making for the super app so they can, apply into every different kind. You don't like it, then make your own. What you needed for the air handle unit, whether satisfy or cooling require, cooling mode, heating mode, and economizer mode. Do you really need economizer mode plus that, do you really need free cooling plus that mechanical cool chill water? Once that mechanical cooling chill water is operated, we don't need any more damper control. If you are opening more outside damper, meaning is you are wasting more energy to chiller side. So you can create your own. That's another things maybe we can attack to customizing that mixed air sequencing. Because that HL is a heat recovery too, but are we, heat recovery, we can think about it, but let's think about the standard mixed air unit. They're not using heat exchange and heat recovery. Just mixed air unit is like a simply what? Hot water coil and then chill water coil and maximum maybe humidifier, but anything else? So we just need like humidifier, we don't care much because humidifier is humidifying it, that's separate, separate loop. But economizer, and then cooling mode, and then heating mode, and satisfaction mode, that 4 main category, that's the only we needed to control in air handler unit. For the, I'm talking about that temperature control wise. Of course, there is a more other, but that is out of the temperature control. If you think about the temperature control, can you think about anything other than four state? When you go to our mode, look at it. We have a satisfied, econ, mechanics, econ plus mechanic, preheat, reheat, cooling idle, heating idle, temperature unreliable. Why need a cooling, heating idle? Once the pit loop is in control in cooling mode, when they satisfy, they will stay at the cooling idle, meaning is stay in the valve where we're at. But we do have an FSM that has like all these features. Well, it's okay, but you cannot predict it exactly when it happened. Anybody has been simulate full functionally an FSM, then yes, you can tell. You can keep changing value here, there. And then once you're doing that, you will get some idea, and then you can just create your own way of that the mixed air single duct temperature control module, FSM. That's another good point. Good target. Because instead of getting a lot of complaining or a lot of unsure the sequence, and change it to your own sequence. I'm not saying that they apply to the job site. Maybe at least you understand yourself to try understand it. Once that is work, then you can just kind of recommend it to your company to using your custom program, custom module to make a standard for your operation. That's working fine. Because once we don't have a reheat enable, this state never going to go on. I told you that is in the state table. This one is I start create a custom program, but when you put the Q&A, they will kind of select the module here, but do they using all the time? No. It all depends on your configuration. So you already know that, I mean, I don't know what's the average of year experience in HVAC world, but some people, to me, that is like pretty much very experienced in it. Then how many different mixed air units we see it? That's mostly standard is what? As I just mentioned it. Damper, economized mixed air damper control, preheat coil control, and then cooling coil control. And if they adding more, yeah, humidifier control. The next is what? Now it's 100% OA side. Now they have exhaust, and whether they have like enthalpy control, enthalpy will control. I mean, there's not many differences. How many times you see reheat valve control in mixed air? I mean, air handler unit. I see very well. And so if you can, I mean, you just question and answer and selected, from the selected system, you built it and you modified here, there to make, make it work. And but if you make one for standard, basic standard one, we just mentioned, economize the damper control, preheat valve control, and cooling control, and fan speed control by the static pressure, and those things in your brain already, and if you make a custom program yourself and validate it, then it's 100% yours. We help to select the system because of Q&A is just helping you or helping our Johnson branches to starting up somewhere. And I always encourage that using that selection system still, it will save time to create the point and stuff. But like economize amount, determination, and fan stop, logic sequencing, and then temperature occupancy sequencing. You can create your own, and just clean out all the unnecessary one, and then just put the main feature in there to select it. So we also gonna we got until Wednesday, so we're gonna try that the standard mixed air unit, and we're gonna try to build up that your own one. So it's challenges. I don't want you to stuck into the our CAN program. I'm telling you, CAN program helping you to start up. But you can do a lot better than our CAN program because you have real experience. I will help you. You end up, maybe you are stuck with some logic or some kind of a sequencing spread out, or like selecting state table. You have a difficulty, then you can ask me some assistance. Then you can send me the CAD file, then I can help. Of course, it'll take time, but I will help. And you're gonna call that any tech support in Johnson side, Brody side, you may get answer. But Johnson tech support, it'll take for a while because those things usually escalate up to level 3. And to come up to level 3, it'll take a while. So any custom program, just give to the Brody proceedings, and then they can just kind of make a channel toward to us, then we can help. And once you like your module, I'm gonna send out to all the branch. Use this. Don't waste time. Don't worry, I'll put your names initially in the front side for the custom module. Yeah, it is. Yeah, just please use that custom module. Don't afraid it. You can test, I told you that you can test with the simulation. You can use it like a dozen times. You can test it any scenario. If you spend a dozen times testing, simulating in one logic, if you pass it, meaning that is a pass, 99%. But if you don't simulate it, then yeah, wish you luck. Don't throw it at the field. Please don't download it. Oh, nothing what happened here. Okay. Yeah, this my initial is all custom. Yeah. Oh, I'm using a lot this one. Sometimes it's some sensor, they are using network input, especially outdoor air temperature, humidity, and plus even zone temp. They are using network input, or sometimes they're using hardware input. So what I done is I kind of create a kind of a selection. So sensor, OA sensor installed or not, you answer in yes and no, then it'll automatically pick the right input and sending out to the whatever related then you require, especially economizer selections, economizer determination. And I just created for them like it's a saving for like whether has it or not. And some branch people, we are Johnson branches nationwide. We are actually limitation on the people to program the CCT, because we have a lot of field tech, but the field tech in each branch is what, less than maybe 10, and we got the more work to do, so we have to give them some solution to saving time, same as you. So you see any idea to saving time? Just like this is simple, but instead of doing every time selecting from the select the system for or hardware output from the miscellaneous, so you select the deselect, and you can just create this kind of one simple logic, and then it'll just do it. So when sensor installed it, then it'll just receive from that OA actually input. If they're not installed it, they ignore this one and then they just bring it from that network input. The gentleman mentioned that is like, hey, there is a zone, the VAD, maybe 4 or 5 of them, supplying using that only one network sensor. And then you can do the network sharing, but if they are on the same trunk, you can use a P2P, point to point. I'm telling you, point to point is a lot steadier and faster, because you don't have to depend on the supervisor controller to sending value, receiving and sending out. Peer to peer, just looking at the target and then just sharing it.
Is it still an issue if if you're in commissioning mode and set up peer-to-peer, lose power, the settings go away? Is that still an issue?
I do not know that's still an issue. I never tried it. I know we had ones that they don't have that issue, but I don't know now.
Yeah, I think in the last release they said it was in the release notes or something.
Yeah.
No. Make sure you do it before you download it.
Yeah. But the peer-to-peer, please, like, yeah, just peer-to-peer is just like, you have to be defined it, and then, yeah, just during the commissioning mode, that's. Yeah, you can. Used to be that the old version, that old release in the CCT, I never had a problem. I can, during the commission mode, I can just changing that, that object, the instant number and so on. But I don't know what release I had some, complaining about it. But, just like, why you changing the, while you're commissioning it, it's better to know, better to know before even downloading it and define the correct object number in the, yeah. Yeah, that thing is like, I did it once, I did quite a time that sometimes I forgot to define the right MAC address And then it's just like, oh, then in the commission mode, I changing it. But when I spending time with the branch office, I never had a problem. But I heard that after that is they have some problem with some release in a CCT. But I don't know. You can test it, and you got CGM, and if you have another controller, try both of them, dump it, and then try the connecting P2P, and see what happens. Because
Is there a way to edit what, say like your discharge air is AI 1019? Is there a way to edit the 1019?
That was one of the questions from that end user. We can change it actually, but you have to sending that the code, the CAD file code to us, and we have to, formula team guys, they can changing it.
But, well, I'm more, like,
I
if we add a miscellaneous point, and you've got a couple different types of VAD.
I know, but just like, I have to have it, like I have to send it out that code to the, our team to changing, because my customer, one really pick a customer, VA hospital. All the analog input has to be starting with 100,000. Some of them is like all the output starting with 200,000. They specified it. So, yeah. Yeah, I understand it, because sometimes if you can organize it, if you can modify it, it'll really be very well organized, isn't it? But it's not. Yeah, just like that is, the gentleman just mentioned about that is changing the AV object number, object identifier. That's a BACnet object ID identifier. That's just a dispute by that, that when you generate it. So, well, yeah. Hey, EGIO can do. Yeah. You can specify that object ID, backcore ID. And yeah. Okay, now, sorry. So, okay, let me just quick pick. I don't care us right now. No reheat. I don't care about that. Yeah, now it's like even under the unit, when you select the table, they will ask you about also that new HVAC code G36. And when you need it, you have to select it. But once that I sending out to that brochure, please read about the G36 and the HVAC 62.1. And if you're really more interested in it, then you have to buy that documents from the HVAC. Yeah. So anybody has like this is a mixed air single that I just created it. And Is anybody understanding this one 100%? Is that how they're working? Because everybody got stuck because of FSM. FSM just doesn't tell you. This FSM is not the logic that you can see it, is a pre-built one, right? And you asking for this control, and it'll just say same thing. So, FSM logic, airflow. And this one is like a helping, at least, if you see this one and then just start, kind of looking around, oh, when is the economizer mode is going to be enabled? When is the economizer plus mechanical enabled? At least you can understand it. And without this, it just blind, you are blind. If end user, customer says, hey, right now, why economizer plus the mechanical cooling? And at least you have to be answer it, and you have to know this flow. This flow is actually for the FSM. So you just, try just to look at it. Simply you go to open up the FSM and go to detail and question mark, helpline, and then it'll just show that FSM flow. And then you can just, kind of if you see, keep reading and reading and reading it, and then you will get understanding it. But if you just kind of bypass it, then if somebody kind of raise hand, then you cannot answer it. So those things, you don't want to really embarrass yourself. As I say, create your own custom program for FSM. And you can do it.
Yeah, it looks like a mess.
Ah.
That looks like some kind of conversation I'm trying to have with my wife about what's for dinner. That's how it goes. That's what it looks like.
Yeah, but if you are really know about this logic and you want to see the code, then you have to get MATLAB software. MATLAB software cost what? $8,500. And then also, just Johnson Formula team's not going to provide a source code. They're not even provide to me. They just give me this one, that's all. But I don't use this one. I just create my own. And used to be at branches because I just create the standard custom program for mixed air single duct, and then with the enthalpy wheel, and then those things. And I separate out, and then I create a spreadsheet, and then I just link to the file location. So whenever who needed it, he can go there, grab that file, pull it out, and download it at the job site. Kind of a custom library so they can pull in easily. Because it's, when you are in project by project lined up, there's not much, especially our, what they call now these days. Our used to be, oh, I forgot that name, but we have a system tech, we have a system designer, and then we have another one, and I don't know, I forgot the name, and the project manager. But that guy, right below the project manager, he handles usually like 40 to 50 projects per year, and he, by himself. And so, we have to create. I have to create for them for like an easy way to grab the file, downloading it, and then commissioning it. To do that is like if you can make a, possibility a lot of Android unit file yourself, customize it, and then that'll be saving time too. Of course, that if people, maybe whoever built that one, if you built that one, your skill is going to be way high. But if somebody from the new guys keep using that one, yeah, they will maybe slow on the growth on the knowledge side, but at least they have a better software than a FSM, those kind of. embedded software, primitive, module things like they're never going to figure out. So filing is the most, library-wise, put your main own library in your organization, and then share with everybody. So once you create one module, put into your main server somewhere, so everybody can pull it out. So instead of you spending maybe 5 hours, maybe the other guys have to spending another 5 hours, you're wasting time, but the saving time. You only spending 5 hours, let the other guy only spend maybe half an hour. I don't know, just like we are using the CCT. Our main CCT was, especially right from the release 14, we were trying to pulling out the library file. So instead of you build, just pulling out the library file from each branches. And it was insisted, but somehow it was kind of now it's like an independent, programming by branches. But I'm telling you, mixed air unit, there's not much differences. Maybe a maximum, 4 or 5 types, that's all. Any other things like, unusual things like, did you ever see that the supply fan more than 2 supply fan? And when you're going to see that more than 2 supply fan? Or even though it's like a fan is a dual fan configuration, how many times you will see it? Maybe once a year? I see sometimes like, sometimes I see only like maybe, no, I didn't even see that even 5-year term wise. Mostly just, you'll see just only difference is like instead of exhaust fan, they put the relief fan. So static, they stack, pressure control maybe. But those things already in the configuration, you can select it. Let's just. You're not asking questions. That's why I kind of threw out to you that some sample from my brain, but yeah, it's already 4 o'clock.
So I guess does it bother like you or anybody else in here that like when you say you wanted to have a network input, like something you wanted to reset, that you have to toggle the point and then toggle it back to say auto or normal or something? There's no way that to have a network input when you turn it on to turn it back off.
Yeah.
So I actually did something that actually worked out. I found some random video online. I don't know if anybody else has dealt with this, but you can use a network output to write back to the network input so that when it times out, it'll reset the point back to normal. So instead of, if a user sets the point to reset, it'll go through that timer and then reset over peer-to-peer back to the input point.
Yeah.
And then reset the point.
But usually those things we actually do at the supervisory devices. And we call it, just call that interlock. So I don't know, so like its own metasys. We're using a lot of things from our SNC, network supervisory devices. Just like PID tuning reset. Once you command it to true, it doesn't matter that already they expire, but that value true is a stay there. So what we've done is we're using, from the supervisory device, we're using interlock feature, same as what you're saying it, but just like after 5 seconds or 10 seconds, time you elapsed it, it'll set back to false. Same idea. But we do not have pulse output. That's the pulsable output. Even the pulsable output, just like, yeah, there's another controller has it. Like after, we just specify that the pulse wide time. Then after that, it left it, it'll back to restore to the default value. But in the enumeration side, you have to really create the different logic. Same as what you're saying, it go send out the network output. But I don't know. It's like I never tried it. That's good thing that we can try. From network output, same device ID MAC address, because in the same internal controller. I don't know if it can be worked that way.
It does work.
It does
That's what I
work.
was sharing.
Yeah.
I was not, yeah.
Yeah. Then you can just do the
Because I
app.
used to drive, because I worked with Delta for a while.
Okay.
You could say, essentially, just use an on-for command. If it's on for 20 seconds, then turn it back off.
Mm-hmm.
But there's no way for me to do that here. And it used to drive, I think I had a problem one time with some lead lag or something that somebody had left it to rotate now.
Oh, okay.
So it was stuck.
Oh.
You follow me? So,
Yep.
I had been trying to figure out a way to essentially toggle, if somebody did a rotate now, that it wouldn't get stuck there, that it would go back to like an auto, a default position of, say, auto.
Okay.
Auto rotate.
Well, that is another thing.
It's-
Like,
It essentially uses a timer, a pulse timer.
Right.
And then to a network output.
Right.
And then you rewrite right back to the same controller at the same peer. But it has to be connected to a network. You can't simulate it.
right. Yeah.
So it has to be like a live controller on the bus for you to do it.
You guys have a CGM, so you can try it.
Well, you also need a network too.
Yeah.
You also need a wire.
Yeah. But just like those things that we usually actually, I know exactly what you're talking about. That's why I told you that on Metasys we are using from that our used to be NAE, now SNC or SNE. We can put the interlock from that in the network supervisor controller. So tuning reset, whatever the commands, we just trigger when it's go true, then we give a 10-second delay time. After 10 seconds expire, we put the false back again. So that is a command through the network supervised devices. So same way, without the network, this one you cannot do that. But if you have a network, instead of doing to this kind of just point to point, those things may be easier to do by that interlock at supervisory devices. Because the supervisory devices, they have an interlock feature. So interlock feature you can create when this condition go to true, or this enumeration go to whatever. After times elapsed by, then you can restore the default enumeration value or false, Boolean side. So once you commanded it, you don't have to worry about that. Put it back to the false or last value, whatever default value is, because that is happening a lot of times. Like once customer says like, hey, I commanded a reset for the alarm reset, and then Fanny is go kicking on and off, on and off, on and off. What's going on? Did you release that alarm reset? No, I didn't. I said, that's why. So you can actually put that the logic, instead of doing that, you can just network input the true, but you can using that the timer to pulsable, so only one shot, give it to them the reset. And after that, it won't bother even though you leave it on true, but that's not safe. So what it does is, if they leave it on true, people sometimes forget. So what it does is like on the supervisory devices, you can create the interlock that point, because you map that point. So you interlock using interlock feature to, if this value turn from false to true, then wait 10 seconds and put it back to false. Then it is automatically that value is go to false. So that's what I usually use from the Metasys side. All the reset, all the PID tuning, those things. And then also the system mode. Some people forget that, oh, testing do something cooling sequence, they put the cooling mode only on the VV boxes, and then they forget to put it back to the auto. And then that controller is always doing the cooling only. So if you created the interlock, when enumeration said if other than auto for more than, say, 60 minutes, put it back to auto. Then it's just, it'll work out. So that's another feature and the supervisory devices. The last time I gave a class at the San Diego was a half day. We were kind of tackling with a SCT level, which there is a more analysis side. So how to utilize that engine, SNC, SNE, to how to program the logic also inside. Because engine, sometimes, SNE, we can have a dual trunk, right? Then we can combine each trunk to each data. They can just kind of share it and then also determine, whatever different types of control. And, very aware, but, they are using a lot for the fire systems, security side. But, just like, we are not recommending anything for the fire side to controlling it, only monitoring it. But they asking, I don't know what they're asking. They're asking something, so I show them, but yeah, just from the supervisory devices, I only encourage you to do the global sharing, and just like interlock future, scheduling. I don't want them to using that LCT, logic programming. Because this logic programming is from the engine, is take more space. The more memory, meaning is that when traffic gets busier, that engine's going to be slowed down. So, but your idea is the same. Because your idea is that if you don't have a supervised device, it's not going to do anything. Yeah. Right. So if you have a supervised device, but just like, where is it? I do have something like that. System reset. On the system reset is a return fan interlock. This is an intermediate, this is happening. But if you make a custom program, we can do reset. So let's say just, so let's just say sample activity, pulse, reset. Say, just say input Boolean, and then timer, and go timer, and default is already pulse. Timer is already pulse default. And then you can define that the time, 5 seconds, whatever. You can say system reset is only just requires 5 seconds. And then you can use this output. Instead of from that, you can use this output to reset that the system reset, alarm, whatever. And then
create a network output.
Oh yeah.
Right.
Yeah. But without even network output. So now once that the reset is commanded to true, from that the network input, it'll only execute for 5 seconds. After 5 seconds, it'll back to the false. But of course that this input, the input side, will stay on.
I couldn't figure out a way I wanted to rewrite it back to it.
Yeah, but
That's the only way I could.
there's only that you have to network devices, supervisory devices. There is no way that you can do it. Because if we do have like
You just write it back to itself. You can do it. I've done it.
yeah.
Yeah. But I'm saying from the controller that you're leaving, you create a network output, and then from that use peer-to-peer.
Right.
To write it right back to its same address on the input side.
Right.
And it'll essentially override the point after the pulse timer is elapsed.
Right.
And then it'll rewrite it back to whatever position you want.
But you still require for the trunk.
Correct,
Yeah.
yeah.
So without the
Well,
trunk.
Right.
Yeah, but instead of doing
What
that,
it does is save you from, if you don't have a supervisor.
right.
And you don't have to do custom programming in the supervisor.
Yeah. Yeah. That is a very long time ago. It was the same question that somebody was raising it, but
There's no, I couldn't figure out a way. Nor
Yeah.
could I get any help
no.
for somebody to tell me, like, just use last value, or
Yeah.
like some tricky little way
Right.
to write the network input point, so there's no way to
Yeah.
create a software point
Yeah.
that, anyway.
That is required for, we call that the defined, especially Boolean side. And some other PLC, they have a, call that the pulsable Boolean input. We do not have that one.
I had this job that I had to do that the customer required us to have, he wanted a button that he could push. 'Cause
Yeah.
it was a test lab.
Right.
For, they had a bunch of chillers and a bunch of stuff, pumps. They wanted all kinds of scenarios for training technicians. And they wanted to be able to, once they were done, essentially manipulating this scenario to where they were having technicians troubleshoot in this lab, he wanted to go on we had to put like an iPad in to where he hit one button that said restore to default, and everything went back to the way it was supposed to be, like, the chillers shut down, the pump shut down, the power shut down, all that stuff. So, yeah, I had to have one button
Oh, yeah.
for him to push on that thing
Yeah.
that said restore system default.
Yeah.
And so to do that, I had to write to like 6 different points.
Mhm.
So, yeah, to do that, then obviously I had to reset the point back to auto.
Yeah, it's the same thing that like one medical center, some medical center, they require at the 800 unit panel, they require momentary push button for the system reset. So they do not want to set from the station. So forget about that, false to true. I mean, false, leaving the false. I mean, true. So what they do is just, push your button, momentary switch it for like 5 seconds and release it, and then reset it. That's another option to sell similar like that. But that's working at the Boolean side. But the enumeration side is different story. So enumeration side, yeah, you have to use that supervisory devices, interlock feature. Right, thanks for attending today, and then let's just start tomorrow same time.
We can just leave this stuff here.